안녕하세요.
Good morning.
2020년 서울 빅데이터
Welcome
포럼
to
둘째 날
Big Data
두
Forum,
번째 세션
Day 2.
과장을 맡은
My name is Kim Sang-il, the moderator of Session 4. I work for Seoul Institute.
알려드린 대로 그 세션 4는
As announced,
주로 도시
Session 4 will discuss issues around urban sensor networks
분석과 그 활용에 대한
regarding evaluation and practical considerations.
IoT 기술이 발전하고 센서가
As IoT technology has emerged and the sensors become cheap,
곳곳에 여러 가지
we have numerous sensors installed around the cities and we collect data from
이번
them.
세션의 주제는
The topic of this
그러한
session
센서들을 설치한 도시들의 경험들을
is centered around use cases of cities around the globe
앞으로의 어떤 가능성 그리고
in order to find some possibilities and some considerations and implications that we can collect all together.
우선 이 세션 4의 참석자들을
I would like to introduce the attendees of session 4.
첫 번째 발표자를 먼저
First, we have four speakers.
고해상도 도시 센서를 이용한 새로운 발견.
The first topic is Finding New Things by High-Resolution Urban Sensor Networks by Research Fellow Park Hae-kyung from Seoul Institute.
미국 시카고대에서 그 네드 잉글리쉬 교수께서는
The second speaker
센서 데이터의 이해라는
is
주제로
Professor Ned English, and he will talk about making sense of sensor data.
노스이스턴 대학의 문희차 교수께서
And Professor Municha from Northeast University will talk about the environment of cities and their spatial extent.
싱가포르의 과우테모크 안다 박사께서도
Dr. Kwautemoku Anda will follow
패널
with the topic of understanding the impact of COVID-19 in Singapore and Australia.
직접 참석해 주신 고경희 서울
And as a panel discussant, we have Director Go Kyung-hee of a Smart City Division of Seoul Metropolitan Government.
서울대학원에서 미세먼지와 관련된 연구를
And we also have Associate Research Fellow Lee So-jin from Seoul Institute, who's highly interested in the air pollution.
김규호 교수님
And we also have a Professor Kim Gyu-ho with us as a panel discussant.
얇은 토론들 부탁드립니다.
And I'm excited to see enthusiastic panel discussion. First, I would like to invite the first speaker, Research Fellow Park Hae-kyung.
안녕하십니까? 저는 도시 센서 네트워크
Good morning, everyone. I'm Research Fellow Park Hae-kyung of Seoul Institute. I'm the first speaker. From now, I'll present a case of newly confirming the spatial pattern of Seoul's temperature under the theme of new discovery using high-resolution city centers. The city of Seoul installed a city sensor called S-DOT at the end of 2019 and began distributing measurement from April 2020 this year. First of all, I think there are a lot of people who do not know about this fact yet. So before I show you the temperature analysis case, I'd like to first introduce the installation status and the measurement, how we have utilized the S-DOT data. And also would like to briefly share the data usage experience. S-DOT stands for Smart Seoul Data of Things, meaning that the smart city can be realized by gathering the data. Currently, there are 850 installed throughout the Seoul, and 2,500 will be installed by 2022. S-DOT was installed to collect information on urban phenomena and citizens' behavior. The aim is to create various values through data provisions, urban disaster prevention through real-time monitoring, realizations of database scientific administrations, and also data convergence, and eventually creating the value.
특정 항목은
The items that we measured include such as fine dust, temperature, humidity, and total of 9 environmental information, and also 1 civic behavior, so total 10. And of these, fine dust is measured to ultra-fine dust, and temperature is measured to the bulb temperature. The square box shown in the photo is a basic sensor that measures 8 environmental information, and at 150 are equipped with the basic sensors. Out of that, 92 of these are installed, as you can see from this photo, is in the form of a basic sensor combined with a specialized sensor that measures wind, temperature, and the number of visitors who are also citizens. The observation period for frequency is usually about 2 minutes, and the visitors counting is measured every 10 minutes among the people within 150 meters. So total of 620,000 data are gathered and generated per day. SDOT is installed mostly at CCTV poles or resident centers in consideration of smooth electricity supply and operation, and there are 448 evenly installed for even distributions of measurement. The remaining 400 are installed in residential areas, commercial area, pollutant discharged area, and wind road analysis areas where special observation is required. And visitor sensors are mainly installed in traditional market area. This is the comparison between SDOT and AOT, especially a Chicago city center, which was reference model when SDOT was designed. The two cities sensors have a differences in installation density. 880 units of SDOT and 150 units of AOT are installed in almost the same area. So in terms of installation density, SDOT is more than 5 times much higher, but Chicago AOT has more items to measure. SDOT measures only fine dust related to air quality, whereas AOT measures a total of 6 items, including fine dust. And there was a difference in the fact that the camera was attached, and this camera is said to be used for urban food analysis in detecting the reservoir. Let me show you the example of using CD sensor data. This is using LACD sensor noise data. And you can see the frequency of noise left to right shows the analysis result, showing that the noise has a tendency over time through the time series. The author of this paper said that the noise has not been considered in urban planning, and the noise as well as the visual urban landscape is related to human health and also comfort and life quality of human being. So in the future, we need to manage noise considering that these deeply impact our daily lives. As mentioned earlier, SDOT data starts from April 1st, 2020 and is being provided in the form of CSV, JSON, and API every 60 minutes. The whole flow from the data collection to users, let me tell you how it is done. The data collected by SDOT sensor is stored in the SDOT database through LTE, and these are sent back to Seoul IoT Data Hub. The Hub DB is also connected to other IoT database, but you can understand that SDB is one of these. The SDOT gathered at this IoT data hub will be open to all users without any restrictions through the Seoul Open Data Plaza site. What you are seeing right now is the CSV file as of October 31st. The model name is the sensor model name, and serial stands for the unique ID of each sensor. So the measurement items are listed in this way, and the units are indicated in the parentheses next to them. Environmental information and visitor information are provided in different files. There is the measurement time at the end of each column. The 60-minute data is simple, arithmetically averaged without corrections or interpolation using the 2-minute raw data. Measurement data and correction data provided only for the fine dust items. I haven't used any other data so far, so if you simply share the experience of using the temperature data that I've used for analysis, which I'm going to do now. Data cleaning is necessary to some extent, but the biggest advantage was that the sensor density was high so that it could reduce the worry of the interpolation of data removal, which is the biggest advantage. If you look at the temperature data of October 31st, out of 850, only about 834 sensors produced data, and as you can see in the middle of the table here, one data is empty, and you can use both value to interpolate. However, in my case, I just excluded the points with mixing values from the analysis. Testing has confirmed that such exclusions do not significantly affect the result of the analysis. If you look at this graph on the left, there are enough samples to form an almost normal distributions, but you can see the outliers. After removing these outliers or zero value, out of 850, 819 were available, or you can use that. So far, I have explained the SDAT, and from now, I will show you the actual case of the analysis that we have used for the temperature data. Let me introduce you the facts newly discovered by using high-resolution city center. First of all, we compared SDAT and the National Weather Observation temperature. What was newly discovered here was that the actual temperature in our daily life was about 1.8 degrees higher than the temperature announced by the Meteorological Administration. In fact, this was the content most interested in, and we believe that this difference is caused due to the different installation environment of the sensor. As you can see here, this is because while national weather observations are conducted in a standardized or somewhat controlled environment, while SDAT is installed in an urban environment such as the roadside, or is very much affected by the surroundings and measures actual living temperature. So I think SDAT measurement is the most realistic temperature. The second new fact in that area that we detected is that Jongno, Hongdae, and Guro, Gansan digital complex are the area with highest temperature in Seoul. You might think, why is that a new fact? Well, you can see here that the existing national observation network, here there was a tendency that the temperature in the region was rather low because there were no observation point in the area. However, using SDAT, these parts were newly observed while mapping them. The third new observation was that the pattern of the temperature change in Seoul over 24 hours. We chose the month of May where the influence of the precipitations or wind is somewhat less, and we averaged the temperature by time, and also we try to observe that. But in the morning, temperature difference between the regions is not so big, but rather small. But from 1 p.m., the temperature in the Seoul center rises above average and gradually begin to expand to the east, and this phenomena continues from 7 p.m. to midnight, and in the evening and midnight past, there was a cycle pattern where the temperature in the region fell back to average. This map shows the temperature at 3 p.m. on the day when the highest temperature in the day was of month of May to October. The fourth new observation from the map that on the heat wave day, even with the same city, the difference in temperature between the hottest and the coldest area in Seoul was about 4 degrees Celsius. The fifth discovery is that the band-shaped spatial patterns that occurs at night on heat wave. While the whole of Seoul was hot during the daytime, couldn't find any understandable spatial patterns, but at night, the spatial trend of the temperature was clearly observed. It is a part that is more easily recognized by looking at the temperature deviation map below. In addition to these spatial patterns, it has observed that the temperature variation between the regions occur more at night than during the daytime. The following is the result of the hot spot analysis of the day and night temperature on the day of the heat wave. Since there are new measurement network and analysis of the temperature hot spot itself was the first to be attempted. Through this analysis, spatial autocorrelation is not observed significantly during the day. At night, spatial autocorrelations of the air temperature is very strong information about the region is found. More interestingly, cold spots during the day are constantly cooler than the hot spots around the clock, while cold spots at night had almost no temperature differences from hot spot during the day, and the temperature dropped rapidly from the peak of the temperature. Then, out of 850 SDOT in total, 89 branches installed in 4 areas: open space, residential space, mountainous area, commercial space. We try to look at the temperature change during the 24-hour span of the heat wave. There was a little difference or almost no differences in temperature during the daytime, but the difference in rate of decrease in temperature was evident from about 4 p.m. The rate of decrease in temperature in mountainous area was the fastest, followed by open space and the residential space, and the slowest was the commercial space. In this way, I will show you the analysis result that can explain why the temperature decline in commercial space is the slowest. In particular, this analysis is analyzed the correlations with the temperature using land cover map, building register data, road name, address map, numerical data in order to understand the urban factors that mitigate or strengthen urban heat island. Among them, a few of the variables that were correlated were shown. The higher the green area ratio, the higher the altitude, the larger the average road width, the lower the temperature. The larger the building area is, the higher the temperature in this area tended to be. Interestingly, most of the variable correlates more strongly with the night temperature, while average road width is more correlated with daytime temperature. Finally, let me summarize the potential of the city sensors based on the experience of using city sensor data. The high-resolution city sensor can detect various phenomena occurring in a small or limited urban space. And if you use in conjunction with other data, you can get more insights. And this data, installed and measured close to our living space, are very realistic and very valuable. In addition, if you would like to give suggestions on some of the issues related to the additional expenses, what we have done is we planned an SDOT. First of all, there is an issue with the number of sensors. In case of the Chicago AOT, there are about 150 with 130 to 20 expansions, but 850 SDOT aren't enough. But I think it has already proven to be the truth. Second is the sensor specification issue. When we received expert advisory opinions while conducting our analysis, there was an opinion that in the case of the fine dust, there is a data reliability problem because the measurement grade is a second grade. Next, let me address the metric issues. As I mentioned earlier, in the comparison, SDOT measures one air quality that is directly related to health, AOT measures 6, and also observes city floods with camera. In addition, there are only 12 specialized sensors of SDOT, for example, wind directions, wind speed sensors, and so it's difficult to grasp the overall trend. Therefore, I think it is necessary to add measurement items of specialized sensor rather than increase the number of the basic sensor. Finally, there is an issue with the installation location. I wonder if you need more time to figure out where additional installation is needed instead of just installing it. I will give you an example. In the case of current wind road analysis and measurement point, it is installed along the Han River, but this is not a place that acts as a wind road. And I think it is very much affected by the water or Han River. So I think we should exclude installing right next to the Han River, but rather at the wind road. And in that case, influence of the waterfront can be excluded. Therefore, I strongly suggest that it would be desirable to take sufficient time to determine appropriate number of the additional items, location, measurement, upgrade of sensor specification after we verify the various cases. These This analysis can be viewed in more detail on the Seoul Institute website. Thank you for your attention.
발표 잘 들었습니다.
Thank you for your presentation. Maybe the SDOT sensor by Seoul Metropolitan Government was established, and since then this may be the first research, and it was a great opportunity to share the interesting facts and the research achievement. And we also got to listen to some suggestions and implications for the further installations of the sensors. Now, we would like to invite the second speaker of Dr. Ned English.
Hello, everyone. Thank you very much for coming to our presentation today. The title of our talk is Making Sense of Sensor Data, How Local Environmental Conditions Add Value to Social Science Research. My name is Ned English, and I'm a senior research methodologist at NORC at the University of Chicago. And I'd like to thank my co-authors, Kevin Brown and Chang Zhao, also at NORC, Kay Cagney, who's in the sociology department at the University of Chicago, and Charlie Catlett at Argonne National Laboratories. And we're very happy to be here at the 2020 Seoul Big Data Forum. Now, if we were in Chicago right now, we could look up and see sensors that look like this. In fact, 140 sensors, small sensors mounted on light posts and the like, that monitor or track real-time environmental conditions. We'll speak in more details about this later on, but this setup is known as the array of things, and it's possible to download publicly available data from the Array of Things website. For years, sociologists, geographers, and others have looked for ways to enrich social science data, whether that's the data collected from surveys or data from administrative records, for example, with other extant information. That is, how does the weather impact people's behavior? How might crime or the perception of crime also impact individual behavior? And the limitation has been, what is the resolution of such information? For example, until Array of Things, the best data for real-time environmental conditions would be from the Environmental Protection Agency, which would be considerably lower resolution across the city of Chicago than the currently, at the time of our paper, 140 sensors that over time are planned to be expanded. So the background for our study or our presentation is we have this array of sensors collecting data in real time about environmental conditions. How can we use that to answer some questions? It's also the nexus of two projects. On the left, we have what's known as the CHART project, or Chicago Health and Aging in Real Time. The PI of the CHART project is Kay Cagney, advised by Charlie Catlett. The purpose of the CHART study is to collect real-time information from older adults in the city of Chicago, including information about where they travel throughout the day and their feelings and social networks. I'll speak more about the details of the CHART study momentarily. But what we're presenting today is how we could enrich the data collected by CHART using the Array of Things project. Here, Charlie Catlett is the principal investigator, as advised by Kay Cagney. Our presentation is thus the overlap between the two. How can we use the data collected by Array of Things to enrich a freestanding survey project, essentially? The design of CHART was to collect real-time information from a sample of older adults in the city of Chicago. As older adults were given smartphones that were designed to collect what are known as EMA surveys, or ecological momentary assessments. These older adults were pinged at random throughout the day and given small surveys. I'll show a screenshot of what these surveys are like momentarily. But prior to the collection of the EMA data, The older adults were given questionnaires to understand their neighborhood context. Do they have social ties in the neighborhood? What is your neighborhood like? Do you feel safe in the neighborhood? Do you have access to transportation, other services? Who is in your household? Who is a member of your social network? Who do you trust? Who could you speak to if you had an issue or an emergency? As well as questionnaire items about physical health, well-being, and socio-demographic characteristics. I think is what special about the chart study is the collection of biomeasures and the real-time collection of ecological momentary assessment, which we'll speak about in more detail shortly. The chart study originally collected 450 respondents who were aged 65 plus across 10 neighborhoods in the city of Chicago. The neighborhoods that were purposefully selected are those outlined in a heavy dashed lines here. The map, for those of you not familiar with the city of Chicago, Chicago is the third largest city in the United States with about 2.8 million inhabitants. It's about a third African American, a third white non-Hispanic, a third Latino, Hispanic or Latino, and the remainder of being Asian or other. So it's a very diverse city. As I mentioned, our 450 respondents were subject to a baseline interview to understand more about them and their physical health. They were then given a smartphone application which administered these ecological momentary assessments as well as tracked their GPS locations. The EMAs were across 1 week using the same application that tracked their GPS locations over a series of 5 random pings per day across a 7-day period. Here's a screenshot of what those EMAs look like. Remember, we're getting 5 of these randomly throughout the day. In this example, it asks you, where are you or where were you when you received this ping? At the time of the ping, who were you with? And how did you feel? Did you feel content? So on one hand, we have this very rich survey data collected by NORC about older adults in the city of Chicago. The question is, can we enrich these data using some extant environmental information? And to that, we turn to the array of things. As I mentioned, this is a network at the time of our research of 140 sensors across the city. The plan over time is to increase that. And the nodes collect different kinds of information. First, there are sensors of environmental data, such as air pressure, humidity, barometric pressure, as well as potentially more interesting variables like the presence of vibrations, loud sounds, and a magnetometer. There are also air quality sensors for nitrogen dioxide, ozone, and other gases and pollutants. There are sensors for the presence of and intensity of light and infrared radiation, as well as the computing power system, essentially. So these are relatively sophisticated devices throughout the city. The map on the left shows the neighborhoods where were purposely selected for our chart study recruitment. The map on the right shows the location of the array of things nodes at the time of our research. Here, each dot shows where a sensor is, as well as a buffer of, I believe it is, 1 mile around each node. So we can see the neighborhoods on the right, which are highlighted in white, are relatively well covered by these nodes. And the question today, or the big picture questions we attempted to answer through our study here, are really fourfold. Firstly, is it possible to feasibly collect location information from a sample of older adults resident in the city of Chicago? Secondly, can we link their location information to extant sensor data? Does that work? Thirdly, do such data to demonstrate some preliminary relationships to health outcomes? Because here the clear application is, do individuals who reside in more polluted areas experience worse health outcomes? And fourthly, do these new high resolution environmental data, do they facilitate novel analyses that we couldn't do previously or otherwise, essentially? To give you a sense about the city of Chicago, I just show these maps to illustrate the city is highly heterogeneous at different scales, meaning socioeconomic data tends to vary at different scales. On the left, we see median household income. On the right, we see the percent of the population that is in our targeted age category, that is age 65 plus. And while we see patterns in median household income, that is the north and northwest and southwest sides of the city are the most affluent, there is still variability at different scales here. There are neighborhoods that pop out as being relatively wealthy or low income. On the right, we see even more heterogeneity with the question of age. I illustrate these to show the importance of having high resolution information to get a more nuanced view or impression of variability in the city. We focused on a subset of the environmental variables I mentioned earlier. We can understand what temperature and humidity are. We also considered a series of 5 gases that are collected by the sensors: ozone, nitrogen dioxide, sulfur dioxide, hydrogen sulfide, and carbon monoxide. And then 2 particulate matter measures, that is PM10 or PM2.5, which we can describe as the solids. Not every sensor collected every measure during our analysis, which we'll discuss a bit more. Nearly all of the sensors collected temperature and humidity data, but only the minority collected PM10 or PM2.5 data. Following downloading the data, we created interpolated surfaces using geographic information systems, analogous to how a weather map is interpolated from temperature readings. Here, we were interested in creating continuous surfaces from point information. That is, the point information from the prior measures we described. And we chose to use inverse distance weighting interpolation, where a cell value is the weighted average of the values from an available set of sample points. And here the weight applied is the inverse distance, meaning closer readings are more important to create the final map than those that are farther away. We can describe the surface that is interpolated as a locationally dependent variable, as it is dependent on the distance to those readings near to it. Here we show 3 maps to give you a sense for the variability of some of the measures of interest here. The map on the left shows mean temperature, in the middle shows mean humidity, and on the right, PM2.5. With temperature, we generally see the warmest readings near Lake Michigan, which is the eastern border of the city of Chicago, as well as the highest temperature readings, but that's not necessarily the case. We see some potentially strange values that pop out. On the right, we see the highest particulate matter on the southwest side of the city, near our secondary Midway Airport, if you're familiar. This might make sense due to the presence of industrial intermodal facilities as well as major highways in these areas. Here we see 3 gas surfaces. The map on the left is nitrogen dioxide, in the middle, hydrogen sulfide, on the right, sulfur dioxide. And generally speaking, we see higher readings for these gases, again, near highways or rail or industrial facilities, but not always the case. We always see some lower gas readings closer to the lake, especially on the south lakefront. The question then, once we have these data, we've created surfaces from point information, is how can we use it? Can we answer some questions then that we couldn't otherwise really answer? And I think the most obvious is related to respiratory health. Do individuals who reside in more polluted areas report worse respiratory health? Unfortunately, in the CHARTS survey, we have an item that covered it. That is, respondents were asked, has a doctor told you that you have emphysema, asthma, chronic bronchitis, or COPD? Yes or no? Here we conducted a series of logistic regressions, controlling for gender, race, ethnicity, age, education, and time resident in the neighborhood, and perhaps the most important, that would be smoking status, as well as interaction effects. Here we can see that about 18% of our respondents said yes to this question. And looking at the results of one of our models, we see that the most significant variable here is individuals who smoke regularly, reported smoking regularly, which makes intuitive sense due to the high correlation or relationship between smoking and reporting many of these pulmonary conditions. But we also see that the interaction between nitrogen dioxide and residence time in the neighborhood was also significant, which makes intuitive sense as well. That is, places with more exposure to this gas interacted with having lived there a long time, make intuitive sense. There could be a positive association with worse lung health or worse respiratory health. Now, let me emphasize, we're not trying to really prove causality here. It's meant to illustrate how these data can be used to add richness to applied questions. And so we feel our research here shows the promise of linking extant data at high resolution to respondent provided information. Now, these environmental variables that we linked are not significant alone. And we also see the limitations of residence time and exposure, meaning while we know you might have lived somewhere, a particular place for a long time, we don't know where you lived previously and what that place was like. There's a number of challenges we found in our study. One is data availability. Not every sensor accurately collected every value all the time. There's also a question of how to link the data sets together. We made decisions about how to interpolate surfaces from these point data, but there are other choices we could have made in doing just that. It requires real expertise to understand what the salience of specific variables might be. We made choices on how to weigh variables, how to weigh the gases and solids that were collected, but perhaps there are threshold values we should have considered. For example, maybe it's not the average intensity of these exposure, it is exposure for a certain length of time above a specific value, which would be more important. Fourthly, we eliminated outliers. That is, we made decisions on what values did not make sense. However, that may be a limitation. Moving ahead, we are in the process of analyzing the real-time GPS data and the interaction with weather. That is, how did weather on a particular day impact individuals' activity spaces? All of this is part of a bigger picture question of how we can identify methods for measuring human activity space and to assess the potential impact of the microenvironment on the activity spaces of older adults. And just very briefly to give you a sense, here we see GPS observations of respondents' activity spaces by neighborhood. We can see they're very different depending on the neighborhood specifically. And finally, I'd like to emphasize that there are a number of error sources here in our analysis. That is, sensor data capture, GPS positional data themselves, the interpolation methods I mentioned, the linkage to the survey data, measurement error around the survey data themselves, and how we interpret it. However, what we're describing here is new measurements or new ways of doing measurements that are not previously possible. Thank you very much for coming to our presentation today, and I look forward to any questions you might have.
고맙습니다.
Thank you very much.
굉장히 인상적이고 흥미로운.
It was very interesting and outstanding result that I can see. In Seoul, we've already installed the centers, and we are in the phase of analyzing these data. But in Chicago, they already moved forward to interconnect with other discipline research. And at our institute and to Seoul Metropolitan Government, I think this presentation is very meaningful and timely. So more questions will come along, and we would like to hear answers from all the speakers after all the presentations. Next.
문희차 교수.
We would like to invite Professor Munhicha.
청해 듣도록 하겠습니다.
Hello, everybody. It's a pleasure to be here today. My name is Maider Jaguna Municha, and the work I will be presenting today has been done in collaboration with Libuse. The title of our talk is Environmental Neighborhoods and Their Spatial Extent, a study of New York City and London. I'll start with the introduction, addressing the motivation, the background research, and the main research questions. I'll follow up with the concept of environmental neighborhoods. I'll define the methodology we developed and the case studies we worked on. And then I'll be showing the results we obtained for New York City and the City of London. And I'll end with the conclusions. So I'm sure that most of you have already seen this quote many times, but we believe it's important to bear in mind that 7 million premature deaths are annually linked to air pollution. More than 80% of people living in urban areas that monitor air pollution are exposed to air quality levels that exceed the World Health Organization limits. We have also recently learned that exposure to poor air quality is also linked to increased death risk from pathogenic respiratory diseases such as SARS, and this has prompted recent media reports projecting these findings to the novel COVID-19. Furthermore, recent advancements in remote and direct sensing technologies have also revealed the environmental inequality present in cities. It has been reported, for example, that air quality concentrations can be 8 times larger within an urban block distance. Thus, urban environmental quality is very much modulated by the anthropogenic and physical attributes of cities. And so by rethinking the design of our cities, we should be able to improve their environmental quality. My research focuses on the study of pre-existing urban fabric conditions and their role in the modulation of the urban environment, the study of urban design and planning strategies that can be implemented to improve the environmental quality in our cities, and the study of urban design and architecture scale interventions to locally improve environmental conditions. So for my research, I developed sensing campaigns, focusing mainly on mobile sensing technologies, as well as data analysis and visualization strategies. So I thought it would be interesting to start from the sensing campaign we deployed back in 2017 in the city of Seoul. We deployed our MAST mobile urban sensing technology, sensing kits that contain air quality as well as temperature and humidity sensors, and they were mapping the city for around a month. And campaigns that also evolved to New York City back in 2018, or more recently within Princeton campus. But once you collect the high spatial temporal resolution environmental data, either through your own sensing campaign or through readily available data sets, we have to make sense of these data. So how do we find the strategies to relate the environmental information with the urban attributes and anthropogenic activities in cities? So this is the focus of our paper on environmental neighborhoods, pretty much defining a methodology to to determine the air quality conditions and environmental conditions overall in a given point in a city. So we define the concept of environmental neighborhood as the area influencing the environmental quality at a given point in a city. So what I'm going to be showing is the methodology we developed to measure its extent. The main research questions of this presentation are: can we distill the linkages between urban environmental measurements and urban characteristics and activity parameters? At what scale are these linkages the strongest? And how can this information guide the design of future cities to improve environmental quality? So we used an air quality data source from New York City, the New York City Community Air Survey, NYCCAS, which is one of the most complete air quality data sets available today. It has data for NO, NO2, ozone, PM2.5, EC, and SO2. It provides biweekly averages and data from 2018 up to 2016. Here on the bottom left, you can see the New York City Community Air Survey integrated filter-based sampling unit. And to the right, I'm showing over an orthographic image, the mean PM concentration over that time frame from 2008 to 2016. And you can see the location of the stations distributed across New York City. Here, similarly, I'm showing two scatter plots on the left of NO2 and on the right of PM2.5. As you can see, the trends are quite similar. These are the mean concentrations, again, over that time frame. However, the trends are already visible here that are substantially different for ozone, shown on the left plot, which drops in the center of Manhattan as opposed to PM2.5 and NO2 that were showing the highest peak in downtown Manhattan. And on the right plot, I'm showing information about the location of these sensing kits. So in pink are the sensing kits that are located at the pedestrian level. The green dots show the stations that are located within parks, and the blue dots show the stations that are located at roof levels, but these are only very, very few. In this slide, I'm showing the intercorrelations of the air quality parameters. As we already could observe qualitatively in the previous plots, PM2.5 and NO2 are highly correlated. NO is also substantially correlated with PM2.5 and NO2. And ozone is negatively correlated with the traffic-related contaminants. So for the urban data sources, we used four main sources, which are the New York City land use data set, 3 foot by 3 foot resolution for tree canopy, grass wrap, bare earth, water, buildings, roads, and other paved surfaces. GIS shapefiles from New York City open data for building footprint and volume, a street center line, and a street tree count. The traffic volume count from 2012-13 database from New York City open data coupled to the Lyon Street database. And the building and tax lot information collected from the primary land use tax lot output Pluto and MapPluto datasets, from where details on the building use and surface areas were studied. Again, as I was showing for the contaminants, this will be the correlation or intercorrelations of the urban parameters. And I'm marking here one of them in red, which is the correlation between the building total area and the non-residential total area, for correlation 0.96. Given this very high correlation, we decided to drop the building total area parameter for the study. And this is just a conceptual diagram that shows the pollution emission sources, or the typical pollution emission sources in a New York City street canyon. That can be primary, secondary, locally formed, etc. So what I would like to focus on is on the methodology we developed to study kind of the extent of the environmental neighborhood. So taking one point in the city as marked in the slide with the white dots, then we started drawing buffer zones around them to different distances and quantifying the urban metrics within those buffer zones. So what we did is for every one of the NYCCAS stations, which here are marked with a red dot, we did a footprint analysis. So we developed footprints from 25 meter times 25 meter to 5 kilometer times 5 kilometer footprints, and computed the metrics for every one of those footprints. You can see there in the caption that goes from 25 to 50 meters to 100 meters to 150 meters to 200 meters, 300 meters, 500 meters, 1 kilometer, 2 kilometers, 3 kilometers, and 5 kilometers. So we got 11 footprints per station location for per every NYCCAS location. And with those metrics, we could start defining these footprint-based correlations with the different urban parameters. So here in the x-axis, I'm showing the footprint size. So as I mentioned, it goes from 25 meters to 5 kilometers. And in the y-axis, I'm showing the person correlation. So for example, for the top right plot, we are looking for the traffic urban parameter correlation against the different contaminants, and different colors depict the different contaminants. For example, the blue is PM2.5, the red is NO2, the pink is the NO, the green is the negative ozone, and the cyan is the EC, the carbon, the black is the SO2. And so we can see already, for example, in the case of traffic, that after about 1,000 meters, after about 1 kilometer, the correlations already start to plateau. On the bottom right, on the other hand, we have the correlations between the green area urban data sets against the different contaminants. The colors coincide with the ones I described for the traffic plot. And in this case, we see that at around 700 meters already, the correlation, or in this case, the negative correlation plateaus, taking into account again that the ozone is negative. So that means that the green areas have a positive correlation with ozone and have a negative correlation with all the other traffic related parameters. On the left now, we see a slightly different trend. So on the top left, we see the correlation between the road urban parameter against the different contaminants. And in this case, we can see that at around 1,000 meters, there is this the highest peak. So after that, the correlation starts dropping substantially. On the other hand, on the bottom left plot, the correlation between the tree count urban parameter against the different contaminants, we can see that around 300 meters, we observe the highest negative correlation. As it was happening with the green in this case, it has a positive correlation with the ozone, and it has a negative correlation with the remaining parameters. And again, after that 300 meter footprint, there is a drop in the correlation. So this is already telling us that for the parameters of roads and trees, for these urban parameters, if we get the footprint scales wrong, the penalization in the results we would be getting would be more substantial than in the case with traffic or greenery. On the left top here, we have building footprint area. In this case, the plateau is the peak, sorry, it's around 1,000 meters. On the bottom left, we have residential total area. In this case, it's less clear, but it looks like the peak is around 300 meters. For the case of the building mean heights on the top right, after about 300 meters or 200 meters, the correlation plateaus. And similarly, for non-residential total area, after about 200 meter footprint size, the correlation plateaus. Also to mention that the two urban parameters that show highest correlations with all the contaminants are the non-residential and height parameters. And again, as for the previous slide, ozone shows negative correlation as opposed to the other traffic-related contaminants for every one of these plots. And from these results, we can conclude that environmental neighborhoods range, at least for the case of New York City, between 200 to 1,000 meters. And in this plot, what you are looking at the relationship between the urban parameters and the New York mean contaminant concentrations averaged across footprint scales from 25 to 1 kilometer. So as we observed in the previous plots, again, the highest correlations are observed between non-residential total areas and heights, mean height urban parameters with all the traffic related contaminants. And the observations are a little bit different for SO2, where the trends are not as clear or as correlated to the other traffic parameters, but especially so for ozone, where a negative correlation is observed as opposed to all the other parameters that are being studied. We also looked at the Breathe London dataset. So the Breathe London project reports real-time air quality data using the AQ Mesh air quality sensing kits. And the sensing kits were installed more or less at 10 feet high to capture the pedestrian level air contaminant concentrations. In this case, they provide hourly averages, and we got about 1 year of data. The sensing kits were installed back in 2018. There are about 100 of them, and in this case, they are reporting NO2 and PM2.5 data. So to the left, we are looking at the PM2.5 plot. To the right, we are looking at the NO2 plot. We are showing the Breathe London station locations and the mean concentrations that were averaged from May 2019 until December 2019. So similarly to what we did for the case of New York City, but in this case we are looking at the diurnal variation, given that the London data provides us hourly data sets. So we are looking at building footprint area versus PM2.5 and NO2 person correlation. So again, in the x-axis, the footprint scale, on the y-axis, the person correlation. And in the colors here depict the different hours of the day. So the blue is from 1 a.m. to 6 a.m. The orange is from 7 a.m. to 12 p.m. The yellow is from 1 p.m. to 6 p.m. And the purple is from 7 p.m. to 12 a.m. So we can see, for example, on the left one, the PM2.5 one, that there is a correlation, highest peak at around 200 meters, that this is particularly the case for the daytime timeframes, not so much for the nighttime ones, while for the NO2 on the right, the correlation is about at 700 meters, and while it's more evident for the daytime hours, the nighttime trends are not as dissimilar as for the PM2.5. And again, we can argue by looking at these results that the trends are similar to the New York City ones, that is, the highest correlations are observed between 200 and 1,000 meters. Here I'm showing the diurnal variation for NO2 for 6 different months, starting from May 2019 on the top left and October 2019 on the bottom right. So you can see that the variation across the different months is not very large. The peak remains consistently within 700 meters, again with highest correlations, especially during the day. These are the same results, but for PM2.5, again, diurnal variation for 6 months, May on the top left and October on the bottom right. In this case, the trends are not as consistent as for the NO2. However, the kind of the peaks remain within 200 and 1,000 meters as reported for New York City. So all combustion-related parameters, PM2.5, NO2, NOEC, SO2 show consistent trends. The highest concentrations are in dense urban environments. Ozone, on the other hand, follows a unique pattern where the highest concentrations are observed in the less dense areas of the city. This is consistent with the literature on the urban formation and patterns of the secondary pollutant. Urban fabric parameters associated with building morphology and building use plays the most critical role in determining the spatiotemporal gradients of air quality. Mean building height and non-residential areas attain the highest magnitudes. negative for ozone, at about 150 meters by 150 meter footprints, while building footprint area or road area affect the local concentrations at spatial extents of about 1,000 meters by 1,000 meters. Tree canopy and grass shrub display negative correlation, again, except with ozone, that peak at about 300 times 300 meters. Diurnal variations affect the correlation coefficient for the studied London dataset case, with highest correlations during the day and especially during the afternoon. During the study time frame, the effect of the seasonal variations on the footprint scale don't seem to be significant for the studied parameters NO2 and PM2.5. And the main takeaways would be that selecting the optimal footprint size is critical for finding robust relations between air quality and urban attributes, that the smaller footprints do not contain all the pertinent information. Larger footprints contain irrelevant, potentially misleading information. Air pollutants and urban attributes do not all evolve similarly, underlying the complexity of airflow in cities, but general trends can be detected. The most important general trend is that for all urban characteristics, the optimal footprint ranges from 200 to 1,000 meters. Like social neighborhoods, environmental neighborhoods in cities are quite limited, and areas with adverse air quality can be improved with localized intervention measures to reduce environmental and health disparities. So I'm going to end here. I'm showing the two papers that we just published and are about to publish related to this work, and I'm also adding an illustration of the NO2 concentration collected from Brit London of the month before and after the COVID-19 lockdown in March 2020. Thank you very much to everybody for your attention.
문희차 교수님 감사합니다.
Thank you, Professor Municha. It was very impressive.
몇 가지 점에서 되게 놀라웠는데요.
I was surprised by a few factors, including Seoul, New York, London, and other cities
비슷한 연구들을
were mentioned with the similar research. To have a cross-check of the facts was interesting, and maybe the research you are doing now related to urban sensor data and will be very beneficial because it can help to decide the density of the collected data, and I am sure your achievement of the research will have a lot of implications on those tasks that we would like to continue.
마지막으로
Last but not least, we would like to
박사님의
introduce
들어보도록 하겠습니다.
Dr. Kwautemok Anda.
In this presentation, we are going to look at mobile phones as urban sensors, as well as some COVID-19 use cases in Singapore and Australia. My name is Kwautemok Anda. My short name is Temo, and I'm a senior data scientist at DataSpark, a startup in Singapore that I'll tell you more about it in the next few slides. I'm honored to be part again of the Seoul Big Data Forum. Last year, I participated coming from academia. This year, I hope I can enrich the conversation with a different perspective, this time coming from the industry. The agenda for today's talk is as follows. First, we're going to discuss how mobile phones can act as urban sensors. Second, we're going to look at some practicalities on what are the challenges and how we have to process this mobile phone data. Third point in the agenda will be on how we have engaged government agencies in Singapore and Australia and provide some COVID-19 related use cases using mobile phone data. And finally, we'll see the outlook in DataSpark related to the upcoming research and development efforts that we have envisioned, mainly transitioning from descriptive analytics to the domain of predictive and prescriptive analytics. So let's start. How can mobile phones be urban sensors? In urban areas, we have dense telecommunication networks deployed. There are thousands of cell towers or cell antennas all around us, bringing in service to our mobile phone devices. While doing so, our mobile phones are in continuous communication with these cell towers. And whenever this communication happens, the cell antennas record a timestamp as well as our mobile device ID. There are two different types of situations in which these location updates happen. First, we have events triggered by the user, for instance, phone calls or when you are using an app that requires internet connection. The other type are location update events triggered by the network. These events happen even if you're not actively using your phone. For instance, when you are crossing between two cell area boundaries, or when your phone has been idle for a couple of hours. What is interesting is that if we take a look at the series of timestamps left along with the locations of the cell antennas, and we plot this on a map, we would see a proxy to the trajectory of a user. In other words, with this location update data, we can reconstruct how the mobile phone users move across the city. In this way, mobile phones are not only a tool of communication, but they also become a sensor of human mobility. The benefits of this are very clear. First, there is no need to invest in new infrastructure. These type of urban sensors are already deployed. Because of this situation, this type of mobile phone data is sometimes called opportunistically collected big data. Another positive point is that this data, different from a survey, is collected continuously, every day, every week, every month, and every year. We have a 24/7 data collection process. It generally captures very large samples of the population. The sample size, depending on the market share by the telco operator. In every city, there is generally a big player that has somewhere between 25% to 70% of the market. And finally, but not less important, is that either if it's a developed or developing city or country, mobile phone penetration rates tend to be very high. Here in Singapore, mobile phone penetration rate is around 98%. And if you think about developing countries, it is more likely that a person there will have a mobile phone rather than a computer. This is a very powerful idea since the solutions you can provide based on mobile phone data, they can be replicated also in developing countries. So what are the negatives or the challenges? The first one is that this type of data is very noisy. It suffers from something called signal jumps. It also doesn't have a fixed temporal resolution. The number of points you get a day by user depends on how much the user uses his or her mobile phone and what type of settings he or she has enabled for mobile data consumption. In contrast with surveys, there is also a lack of context. We may see how a person is moving during a day, but we do not have an understanding of why this happens. In general, this can be summed up as mobile phone data is not readily useful if we want to derive mobility insights. For this, we first require to do some processing work. And this is where DataSpark comes in place. DataSpark works closely with telcos in Southeast Asia and Australia to collect, clean, align, and enhance mobile phone data. We first receive raw data from the cell towers, we clean it and ensure it meets strict privacy and security standards. Then we align the data to be able to look at location, trip, and people attributes. After data is aligned, we enhance it, mainly by doing an extrapolation to present population-wide insights. Finally, we convert it into a series of APIs that serve currently several transport and planning agencies as well as different types of industry. More specific, part of the process we do to enrich the data is to use some information from how the cell tower is deployed, as well as some GPS data to enhance the spatial accuracy. We do the oscillation removal, which is the signal jumping from tower to tower despite the user not being moving. We find cluster of points where the person has stayed, and we find movement corridors when the user is traveling from stay point to stay point. Another relevant point is that as 5G technology comes in, we will be looking at better temporal and spatial resolutions when dealing with mobile phone data, and possibly new types of algorithms will be required to process it. The data extrapolation is required to complement the users that are not subscribed to the current telco operator. For instance, in the case of Australia, we first differentiate whether the mobile phone is from a local resident or from a tourist. If a local resident, we use the user's home location and other demographic data to create a relative weight for the person. Those relative weights are calculated in a way to match the Australia Bureau of Statistics data. If we detect that the user is a tourist, then we use data provided by the Tourism Research Australia to derive a similar relative weight. Then we employ 3 different datasets to validate this extrapolation effort, those being smart card public transport data, direct information from Australia Tourism and Immigration, and also information on some ticketed events. After all this processing is done, finally, we arrive at our building blocks to be able to draw mobility insights. These building blocks are provided in the form of APIs, and we have 3 main APIs. The discrete visit API tells where and when are people present at certain locations and how many people are there. The stay point API tells where do people stop to spend time. And the trip API, where do people come from and where do they go next? What mode of transport did they use and what route did they take? As mentioned before, the strengths of this data are its timeliness, the large sample sizes, and the large spatial and temporal coverage. About timeliness, for example, APIs for planning purposes are enabled with a latency of 2 days. But just this year, we released a real-time dashboard where data is made available with a 5-minute latency. We can further analyze the movement patterns we see in mobile phone data by personal attributes. Some of them are coming directly from the telco data like age, gender, and country of origin, and others we have derived based on the behaviors observed in the data, like home and work locations. Here is an example of a person's daily timeline. The upper part is organized by our stay point and trip API. As you can see, the day starts with a stay point at home from midnight to 7:45 a.m. The stay point API gives you information about the start time, end time, duration, and location. Then there is a trip block from 7:45 to 8:30 a.m. The trip API not only has information about the start time, end time, and duration, but also gives information about the route taken. There is a map matching effort to allocate the specific links used in the transport network. We also provide information related to the mode of transport. As the day progresses, as you can see, everything is organized as a sequence of stay points and trips. On the lower part, we can see the same day, but organized in the discrete visit blocks. The discrete visit API shows where a person is at every 15-minute time interval. So when you are interested on crowding, how many people are at a certain place, no matter if they are staying or just passing by, the discrete visit API gives you that count. These APIs are then made available to our transport planning agencies, other government agencies, as well as other industry customers. The type of analysis and applications on top that can be done can be divided into monitoring, planning, and policy. We are going to see on the next slides some of the applications that have helped the Singapore and Australia government in relation to the COVID-19 events. First, we have here an analysis on the impact of COVID-19 in the retail industry in Singapore. On this graph, we are looking at the year-on-year change in total footfall in shopping malls in the central region of Singapore, the majority being on Orchard Road. Each horizontal line relates to one of these shopping malls, and the vertical bars refer to a particular COVID-19 event. We can see that the first imported case of COVID-19 shows a moderate drop in visitors. Then we have a bigger drop. That one caused because of Chinese New Year, where many shops are closed or operating at low capacity. After Chinese New Year, we can see that the visitation to these shopping malls starts recovering till the first local Singaporean case. The last part is very interesting. There is a substantial rise followed by a heavy drop caused when Singapore raised the doorstorm alarm system to orange. Before the alarm went to orange, people knew it already, so the previous weekend there was some panic shopping. For this reason, we see that there exactly this weekend where people went out to buy groceries. And we see this increase in footfall before the alarm was set to orange. In general, we see that the drop in visitors for this type of touristy malls along Orchard Road follows the COVID-19 related events. Now, when we analyze shopping malls that are located in the suburban areas, we can see that those type of residential malls were not that affected. They also had the panic weekend effect, as we can see there, before the alarm was raised to orange, but they were kept reasonably stable compared to the trend before. Another way in which we have contributed is through the Singapore government Space Out project. We have provided our data to help in the real-time crowding counting of different types of places of interest like shopping malls, grocery stores, parks, and libraries. Any person can access an online map where they can check the current level of crowdedness in these places. And they are given alternative suggestions, for example, if their local grocery store is overcrowded at the moment. Meanwhile, in Australia, we had worked closely with transport, tourist, and health agencies. This chart was published in the Australia Transport and Tourism Forum in August 2020. We can see here how COVID-19 has impacted the mobility of Australians by each of the states. In total, there has been a 52.7% decrease in distance travel, 26.7% increased on time spent at home, and 36.6% decrease in the total daily trips. And we can see these specific statistics for each of the states in Australia and how they differ from one each other. Here are some comparisons between the most important Australian central business districts on visitation behavior. These are the percentage of people in those CBDs from February to July. We can see how the lockdown measurements have impacted. It is also interesting to see how it varies from Melbourne and Sydney, where the drop was kept for several months, against, for example, Darwin, where there is a clear drop in April, but then after May it went back to normal. Aside from the mobility insights, we have also provided to the government agencies some interactive dashboards where you can analyze different areas in Australia and get some immediate mobility-related insights. Here we have the community movement dashboard, where we can see the average time spent at home. That can be used to monitor the isolation and social distancing measurements by every location. In the lower blue plot, we can see the difference in average time spent at home for the specific area of Glebe and Forest Lodge. As observed, this average time spent at home was kept along the baseline for the month of February and the first part of March. Then we can see the increment of people staying at home after March 15. In the same community movement dashboard, we can also analyze trips by areas. Here on the lower blue graph, we look into the Haymarket and the Rocks areas in Sydney and how the number of trips decreased substantially in the month of April. Finally, we have also made available to the Australian government a real-time dashboard where you can see mobility indicators with a 5 to 10 minute latency. In the graphs below, we can check in real time the number of people staying versus the number of people traveling in the Haymarket and the Rocks area in Sydney. Lastly, I want to talk about the outlook we have at DataSpark, and specifically to the one that relates to the research and development effort we have recently started. So far, all the use cases that we saw can be considered as descriptive analytics. They are analysis done on historical to real-time data. The next step for us is to start tapping into predictive analytics to look at short and medium-term predictions, and prescriptive analytics, meaning what type of interventions need to be done in order to change the mobility behavior in a city in a particular way. For the predictive analytics part, we are thinking on leveraging on deep learning as a way to unlock the hidden correlations in large historical and cross-sectional datasets. And for the prescriptive analytics, we are looking into agent-based modeling for transport planning. These are data-intensive simulations for large-scale what-if scenario analysis. We are currently building strategies to tackle these new challenges together with academia and other industries. Hopefully, next year, I can report on the research and development outputs of these efforts. Thanks very much. I'll be happy to answer questions later today, but also feel free to send me an email to temo.anda@dsanalytics.com. Also, you can add me on LinkedIn with my full name, Cuauhtemoc Anda, and also take a look at my research output on Google Scholar. Thanks.
고맙습니다.
Thank you very much,
테모 박사님.
Dr. Temo.
안다 박사님의 이
Dr. Anda.
연구 결과는 정말 듣는 내내
His very interesting results of research.
서울시도
The more I listen,
핸드폰
in fact, in Seoul metropolitan government also uses the cell phone data signal in order to find out how many people are gathered in which areas of Seoul. And we've been announcing and releasing the statistics to the general public. And I believe what Dr. Anda has developed is more of the raw data centric analysis and the research, which was pretty amazing. And let us get into the panel discussion. And I believe we all have our presenters and discussants. Once again, welcome all online or on site.
본격적인 토론에
Before we begin,
발표하신 내용들에 대한 간단한
maybe we want to collect some simple questions based on these presentations, if you have it among you guys, and then
발표하신 자료들에 대한
based on
주제들에 대해서 좀
the topics we can briefly talk about before answering some questions. And to wrap up, maybe we can think of the public data responsibilities and maybe more in a broader picture sense of discussion I would hope to see towards the end.
먼저 질문을 좀 드리고 싶은
First, I would like to ask a few questions as a moderator.
일단 네드 잉글리시 박사
First, I would like to ask Dr. Ned English.
Sure.
네.
Okay.
그 여러 가지 예.
I don't have any questions at this point. I'll defer, if that's possible.
네네. 근데 그 보관법을
But I guess my main question is, what is the nature of the network in Seoul? Like, I know you talked about the density of the network somewhat, but how recent are the sensors and when did they first come online?
지금 네드 박사님의 질문에 대해서
To answer
박사님께서 좀
that question, maybe Dr. Park can answer briefly, perhaps?
제가 정확히 질문을 이해했는지 모르겠는데
I don't know if I understood correctly, but let me try to answer.
드렸지만
As I mentioned before,
올해 4월부터
we started this project since April this year. We began to distribute the data, so we don't have actual numerous cases of analyzing that.
제가 그 기온 분석 같은 경우는
In case of the temperature analysis, I am the first one to do that, and I sincerely hope that if my work is widely known, I believe that also the tools that I have used, other people, other scholars will start doing the research. So we haven't gathered a lot of information yet, and when the data are accumulated more and more, there will be more actual use case. I don't know if I answer correctly.
Yes, thank you. Yes, thank you very much.
그 네드 잉글리시 박사님의 그 연구 중에서 제가
So among what Dr. English mentioned,
저의 뭐 일종의 제안은
maybe some sort of suggestion from me, maybe with the existing sensor data,
유의성을 갖다 한번 검증하는
Maybe it would be great to validate the existing data. And you mentioned about let's say five sensors, and maybe we exclude one sensor and we try to compare when you replace the other sensor, and then let's say you have a set of five sensors, and then by replacing each and one of them, and maybe you can validate the data efficiency and data availability, and that way maybe you can make up some defects and issues of the existing sensors, and that's my suggestion. And
태모 박사께 좀
also
봤습니다. 그 태모
okay, then I also want to ask Dr. Temo, Dr. Anda,
제 말씀 들리시나요?
can you hear me?
Yes, I can hear you.
아, 예, 예. 그 저는
Okay.
데이터 스파크라고 하는 조직이 굉장히
I'm very interested in your organization called Data Spark.
민간의 자료에
Because while you're approaching the private data, but in methodology and some collaboration method is quite different from other conventional private organizations. And I'm curious about the main roles and what is happening in Data Sparks. Perhaps you can elaborate a little bit?
Yes, thank you for the question. So the way DataSpark is a startup within the Singtel Group. So Singtel Group owns different telcos or has some share in some telcos around Southeast Asia and also Australia. So because of this link, then that's how DataSpark is the part of Singtel Group that processes the mobile phone data mainly for two purposes. So the first one is to make use of the data to provide some feedback on how the telco network should be rolled out or upgrade. So it's some optimization on the infrastructure of the telco. That's the inside use case. But then we believe that this data can benefit, for example, for a good cause, right? Like for transport planning and in general for urban planning. So that's the other use case we are exploring, or we have explored, how to make use of this data that normally telcos use for their own interest and make it also useful for transport and urban agencies. This second one is a little bit more of a challenge because of the privacy regulations. In Singapore and in Australia, there are very strict privacy regulations. So everything we do, all the research and development needs to be aligned with these regulations, and different to maybe other type of data research. This means that, there's always, more challenges to tackle. We cannot speed up the research and development sometimes as we wish, but we understand that the priority is to protect mobile phone users' privacy.
후반부에 좀 더 정리를 하는 얘기들을 좀 나눠야.
Maybe towards the end I will revisit you with your insight, but then the public sectors sometimes have an issues dealing with a certain data, and it was interesting to hear the roles of the data sparks. I would like to ask another question to Professor Municha.
그 논문의 내용들을 갖다 충분히 이해했는지는.
I don't know if I understood every items that you have mentioned in your presentation, but let me pose a question. Well, the unit of the space that has environmental implication or significance is what I understood. The same methodology, maybe we can apply not only to the environmental area, but we can apply to temperature, noise, or humidity measurement, or any other things that you have not even think about. But is it possible to expand your research? Is it possible? I'd like to hear your views.
Well, thank you very much for the question. This is exactly what we are trying to do right now, and I would be very interested in looking into your S.dot dataset actually, but we are working on right now on the city of Los Angeles for which we have relative humidity, temperature, and PM 2.5 data. And we have very many stations. There are over 300 station data. So this is a research we're doing, and we are finding interesting similarities with what I have reported to be the environmental neighborhoods today for the air contaminants. But for the City of London, we haven't had the chance, for example, to look into the temperature data, neither for the City of New York. So the first one we are looking into is Los Angeles. So we haven't been able to compare those conclusions with any other city yet, since we haven't found any high density sensing network as what we are finding in Los Angeles. So as I said, we'll be very excited to look into your data set. And I was very impressed with the work of Dr. Park and her team.
지금 이제 토론자분들의 말씀을 이제 좀 들어보고 싶습니다.
Now I would like to invite panel discussants. After listening all these wonderful presentations, I'm curious what these panel discussants think and what kind of questions they have to the presenters. First, I would like to invite
도메인 날리지를
fellow researcher Lee So-jin.
좀 해주시면
Maybe domain knowledge related discussion can be led by you.
조장님 제가 정확히 질문
Could you repeat the question once again?
지금 발표하신 내용들 중에
So based on the
그
presentation, some sensors are used for weather conditions and some air pollutions, and there have been some sensors introduced during the presentation. And so maybe you can include these data related to air pollution and weather conditions. So maybe because it's one of your expertise, and maybe you can bring some suggestions or some feedback or questions. Good morning, my name is Lee So-jin from Seoul Institute. Maybe it's my personal concern.
로우 코스트 센서로 지금 미세먼지랑
By Seoul metropolitan government,
그래서
there are some research conducting with a low budget, and then it's because low-cost sensors.
이제 항상
When it comes to low-cost sensors, there's always an issue of the accuracy, and we have a lot of sensors by low-cost sensor, and if it's consistent, at least depending on the local district offices of Seoul, but it's actually very hard to pull out the tendency, and we are wondering whether they have a similar impact. And I heard some interpolation. We have a lot of concerns to deal with this information and data. So by utilizing the PM data, what we like to ultimately see is that, as one of the presenters mentioned,
기존 연구 같은 경우는 뭐 대부분의 위에
it's a temperature analysis, and maybe the risk analysis, and then these existing risk analysis is mainly done by government agencies, and we had some researches around that, and based on that research, when we just simply applying low-cost sensor data,
실제 그 통제된
probably
위해서 측정된 값보다 과대평가될 수
maybe this is overestimate or underestimate depending on the condition of the low-cost sensors. So that way,
측면에서
in terms of the risk analysis,
좀 정확도가 높은
maybe
를 사용해서 위에서
we need to use more accurate information. For example, the density of the PM 2.5 and how many casualties we expect in the future. But by applying low-cost sensors, we rather provide some fears to the general public. So I always concern that the low-cost sensors, in terms of density,
정확도를 유지하는
are pretty decent, but in terms of data accuracy, it's always my personal concern. And I've looked into some cases, and especially in California, they have a popular sensor, and then
민간에서 판매를 해서 각 가정에서
it's sold by the private sector, and it's used in households.
사우스 코스트 에어
Maybe South Coast Air Quality District they have some cases, and periodically they also do some monitoring with the more expensive and accurate machines around the low-cost sensors to enhance the accuracy of the low-cost sensors. So in order to maintain the low-cost sensor quality, it is the accuracy that is the key, and I guess we have to keep providing decent monitoring on a regular basis. And I heard some cases of New York earlier, and then maybe it's important to provide real-time data, but it's also important filter-based measurement, because it's also important to utilize filter-based information, because that can provide maybe some supplementary solutions. And I think that is my thought after listening to all these presentations.
이소진 박사께서는
So according to Dr. 이소진,
한계일 수도 있는
maybe this is the profound limitation of the urban sensors. By utilizing these sensors, we
한계
inevitably encounter some issues, and maybe to solve that, you talked about two improvement measures in quality to enhance the accuracy of the data. So while enhancing accuracy, it's also important to give some reliability to the users of the data. But at this moment, maybe as that data and its measures to be expanded, maybe I think it's a timely and appropriate suggestion.
토론을 좀 부탁드려야겠는데.
I would like to ask another panel discussant, Professor Kim Gyu-ho.
같은 이런 IoT 기반의 센싱
Based on IoT,
가지고 계시고 또 이런 SDAT 데이터
you have some experience, and in the course of installing SDAT, I believe you are highly related.
I am Kim Gyu-ho. Well, I was very much impressed with the presentation given by Professor Municha. Personally, I have installed sensor right in front of my house, and I have gathered information. I tried to compare. What I found out as a result of that is, in case of Chicago or New York, you know that there are not like a fine dust that comes from other neighboring countries. But in case of Korea, we suffer a lot from the fine dust coming from China during the spring season. But upon gathering the information, I found out the correlations. I could detect whether the fine dust is from the local origin or it's from China. I don't have mathematical or arithmetic calculation special capabilities, but Professor Municha, you have come up with the model and methodology, and then you try to analyze what's the correlations, try to identify the reason. So I believe if we can do that in Korea, maybe we can measure the fine dust origin in China or the neighboring countries. So do you think it's possible?
Yes, actually, I did briefly mention in the presentation this very small experimental campaign that we organized as part of the Seoul Architecture and Urbanism Biennale. And back then, the organizers that were from the city of Seoul, they mentioned that specific question that you raised about the particulate matter being transported, and one of the hypotheses being that it was coming either from the area of the shoreline in the coast or eventually from China, and what was the percentage of that coming from there. And that was a discussion, so I very much appreciate your question. I do believe so that we should be able to with maybe an axial footprint analysis, maybe by weighting, the directionality of that correlation to identify, a more, larger scale pattern, how that can be, to what extent we could accurately identify the percentage that is being transported or not, we will have to look into. I remember back then we came across publications that said about 50% of these particulate matter contaminants were being transported from far away, and most of them were local. But this is something that we were not able to reveal through our experimental campaign because it was very short. We only had 3 sensing boxes active on the buses, given the budget and so on. So we couldn't find any answers to this question. But this is certainly a question that I find fascinating, and with all the political and environmental implications it brings along. Yeah.
사실은 저도 이제 PM 2.5하고 PM 10을 이렇게 비교를 보면
When I compare PM 2.5 and PM 10,
만약에 황사
let's say the yellow dust is related to PM10 and it increases, and the NOx group, maybe from combustion gas from vehicles, and I tried to look more into, but my research didn't pull out decent data. So once we have some research for that, it will be very helpful. And also,
네드 박사님 발표하신 거에 대한
I'm interested in some parts of Professor English's presentation, and
비헤이비어들이 있죠.
we have some behavior that we can assume before the research, and it was very interesting that you actually look into these assumptions and prove it with some data. But when you combine these data from sensors, you turn that assumption into the figure, and maybe what kind of facts that did you find newly that you couldn't assume before?
I think that's an excellent question. And I'd like to also go back to one of the observations that was made a moment ago or a few minutes ago about the issue with low-cost sensors and questionable data. I think that's a real limitation, at least in our analysis, that I think contributed to some of the data issues that we found was questionable data due to low-cost sensors. But to answer your question, I think with our preliminary analysis, we found fewer patterns than we might have hoped, because I think our preliminary analysis was confounded by a number of factors. And I think the most important factor that we focused on was the confounding of smoking. So we couldn't separate if someone had poor lung health because of smoking history or because they lived in a more polluted area. So actually, we found fewer correlations than we had hoped for. However, the next phase of our analysis will take advantage of the GPS data points that I briefly showed in our presentation. The analysis we showed was based on the home location. That's not based on all where somebody traveled, if that makes sense. So we would like to bring in other factors, including climate and weather, how that might impact outcomes beyond their home location. So I think to answer your question, we actually found fewer associations between pollution and reported health than we expected, at least in our preliminary analysis, due to confounding factors and probably the fact that the outcome variable was confounded with smoking. And it might be that the scale of the variability we were trying to measure, maybe it was too small. Maybe the pollutants actually don't vary enough on the scale of the city of Chicago to matter to health outcomes. That could be something too.
그 동일한 질문을 우리 또 안다 박사님께
Maybe I will ask the same question to Professor Anda, Dr. Anda.
대략 추정으로서 알고 있고 가끔 데이터
We have some data that we easily assume and predict before the research, but based on your accurate research and then other than what you establish the result of the research from your assumption, is there anything that you also newly found from your research?
Yeah, I think like here one of the interesting points of doing research on mobile phone data is in how can you actually manage to design some useful application out of it, and something that it's really required, for example, by transport agencies, by planning agencies. I think there is a gap from working with raw mobile phone data or raw urban sensor data to application, and that gap can be divided into. So there's a first part that it's associated on like normally this data as we have been looking. You need to do some processing effort because there is noise, there is outliers, and especially with mobile phone data that is the case. So first there is this gap that you need to have the correct capabilities to process the data. So in order to start giving some insights and some findings. Then the second gap, I think it's even more interesting. So once you have figured out a way, you have the capabilities to process the data and clean up, then from there you need to see how are you gonna embed that clean data into some current process, whether it's a planning process or an operation, and make it readily useful for an application. So, for example, at this point, we, similar to the efforts in Seoul, we have the crowding counts, right? So it's a very straightforward application once you have cleaned up the data. But then we are thinking like the last part is how you go from not only providing crowding count, but how can you, for example, embed this into transport models, or how do you embed this into other type of applications, or how can you make more use of this data, right? And I think that's like the research now is focusing on this part. So when all these mobile phone data started emerging, specifically or more specially on transportation research, this was about like 2010. So papers around those years were focused on the first part of how we process the data, how we clean up, how do we get origin destination matrices from mobile phone data. I think that part is I think mostly solved. And now what we are looking is, okay, now how do we really make it useful, and how can we implement this in, to drive city policies and to plan infrastructure, in a data-driven way. So I think those are the gaps, and I think that's where we are currently on.
감사합니다.
Thank you.
김규호 교수님께서는 뭐 다른 코멘트들은
Professor Kim Kyu-ho, do you have any other comment or questions? None?
일단 지금 서울시의 이
Well, Seoul Metropolitan City Government has its own sensor policy, and we have with us the person in charge of the smart city. We have Director Ko Kyung-hee from Smart City Divisions of Seoul Metropolitan City Government. Hello, everyone. I am Director Ko Kyung-hee in charge of the smart city. I enjoyed tremendously. I learned a lot and also insight from the presentation. Thank you so much for the impressive presentation. Well, Seoul Metropolitan City Government, in case of the research fellow Park Hae-kyung's presentation, as she mentioned, we are trying to utilize SDOT, which is using the sensor to measure the temperature. Well, Seoul Metropolitan City Government really would like to use IoT AOT, gather data and try to understand how this data that we have gathered can be beneficial to the citizens. We read the Chicago's AOT and we wanted to do something like what Chicago did. But of course, we would like to make it more appropriate for Seoul City in terms of the items, the installation locations, and also after we measure how we are going to use that. So starting from the last year, we started this project in full-fledged manner. More than 800 sensors are installed over Seoul, and we are gathering all kinds of data. And research fellow Park Hae-kyung made a presentations about the temperature. Well, upon listening to the presentation by all four speakers, the impression that I have is that Seoul metropolitan government is in infant stage in terms of using big data. We only thought about gathering the data from big sensor. We never thought about how to expand the items like the humidity, the other air quality, or other thing, how we can combine the data, how we can utilize the, how interpret that. We didn't even go to that stage. So I realized that we have a long way to go. And I have a lot of questions in my mind popping here and there, but I will not ask overlapping questions. I'd like to ask a question to senior researcher Ned.
In terms of installation of sensors, and as a local government or public organizations, we create some budget and help these organizations to find a location and decide the final installation location. But in terms of Chicago, I wonder if there's any government role or intervention or any support when you carry out this research and sensor installation. I would like to hear more about it.
Certainly. Now, let me provide the caveat that I wasn't directly involved in this part of it, but my understanding is while the project was funded from the National Science Foundation, so from a federal government agency, the city of Chicago provided direct support to the installation. I believe they provided support from electrical crews, for example, to help install the sensors themselves. When the research team would recommend locations, the city would support the actual physical, the cost and expense of, for example, sending a crew with a truck to install the sensors on light posts and provide the electrical power. So the city level of government would provide that level of support. However, the cost of the sensors themselves, the larger cost, was provided by the United States federal government through what's known as the National Science Foundation. So it was a partnership in a way between the municipal government and the federal government through the actual scientists at Argonne National Laboratories.
Then, as one of our topics mentioned, you mentioned about utilizing the older respondents' information to utilize better sensors, and maybe with this urban data, what are some first-hand experience or impression of the general public? Do you have any other use cases to give an example for more like a first-hand experience and impression or of the general public of Chicago?
The impression of the general public of the sensors themselves. You mean what is the public? How do they feel about these sensors? For clarification, okay, yeah. That is an excellent question. And I'm really not sure what the general public thinks about it. I do think in the city of Chicago, we have a history of having cameras and other sensors. Like many Western cities, I think the public is used to having, say, police cameras or police sensors, which predate the array of things. For example, it's not unusual to have cameras, security type cameras. And so I think the public might be used to the idea of more sophisticated sensors. Occasionally, it'll be the array of things will be discussed in the popular media, in the news. And I think it's become more normative, the idea of having sensors. But that is an excellent question. I don't think the public is concerned.
Thank you for answering my question. And next, I would like to ask a question to Professor Municha.
My question, actually, it's not a question, but rather it's a proposal, because you discussed ozone O3, or also your plan that you will do more research, or you are doing a research in LA, and also you are doing a humidity research. But let me tell you one thing, Seoul City, together with the data we are gathering a lot of data, but among those data, we are very much focused on the humidity data, temperature data. We already have huge data, huge amount of data. And starting from December this year, what you mentioned, NH3 or H2S or CONO2, all of these things we are trying to gather from this December. So this is our plan. And since you are doing it, why don't you use our own data? We can share our own data via online. These are the open source data. So Dr. Municha, if you ask to Seoul City or to me, I can definitely give you all kinds of data, and then probably you can make a report or you can write a paper introducing the case of Seoul. That is my hope and expectation. However, Professor Municha, I have one question. Based on our plan, 1,100 sensors are already built within Seoul area, but still, we believe that we need to build more, because in terms of the accuracy and credibility or reliability, we don't think that it's enough, because we don't have anything to compare. And I've been asking to the citizens, do you think I need to disclose all of this information? Because this is quite sensitive, so I don't know, should I open this data or not? I haven't decided. I don't know if this is right or not. So regarding the IoT sensor network, can you give some advice? I mean, how can we improve the accuracy of the IoT sensor? If you give advice, it will be very helpful to me.
Yeah, thank you very much for all your feedback and comments and the question. First of all, thank you for letting me know that your data is going to be available from December on. That's very exciting news. Actually, we were not aware about your campaign or your network until I heard about the forum. So I really appreciate that, and we'll be very excited to work with your data. As for the question of the accuracy, and it relates back with the comment that was raised at the beginning of the conversation, the Los Angeles data that I mentioned about is actually using the Purple Air dataset that it was mentioned at the beginning of the forum. And this is a low-cost sensor network that is privately owned. And a portion of these sensors can be located inside, and some of them are outside. But these could be located in any location, really, from a backyard to the street, right? And you don't know exactly whether it's within a street canyon or whether it's in the backyard, right? So we are facing many challenges to really try to, process that data properly and work with that data so that we are sure that the results that we are reporting are accurate. The advantage is that it's a very dense network as opposed to the New York City one, which is a network that uses high-end sensors. They are located nearly 100 of them at the pedestrian level, or approximately 9 feet tall. And those were, wouldn't require all the processes we are following now to kind of process the Los Angeles data. So having said that, I'm not fully aware of, the protocols you are following for the installation, the type of sensors you are using, the criteria you have used to locate the sensors, and all of these parameters would completely, affect the how we can make sense of that data. I remember Dr. Park mentioning that the data that she had to remove from the temperature data was very low. If I remember correctly, she was keeping up to 815. I mean, that's like excellent. So that is already, setting the standards, high. So it very much depends on the sensor quality. I worked with local sensing platforms and high-end platforms, and it's a very complete, it's a very different exercise. And of course, then if you jump to mobile sensing, it gets even more complicated. I don't know whether you even contemplated that within the Smart City program. But yes, I would need to understand better about, the calibration processes you follow, the location of the stations and the sensors that you are using.
네, 교수님 답변 감사드리고요.
Thank you for your answer. So personally, I should keep in touch to share useful information from both sides, and I will continue contacting. Last, I want to ask Dr. Anda a question.
서울시에서 같이 고민하고 있는
Something that we can collaborate, and I will add some question regarding the possibility of collaboration. We have mobile sensors in Seoul also
서비스를 제공하는 부분이 굉장히
to provide public services, for example, to respond to COVID-19. Weekly, we have a collaboration with telecommunication companies to collect all the mobile data because we are interested in some population inflow into Seoul who are not residing in Seoul, just outside of the Seoul they are living. And it's important to see the trend of the inflow of the outside population of Seoul. So compared to last year, due to COVID-19, the figure drastically dropped, and we are working on that analysis. And another factor we are interested in is in collaboration with the credit card companies. And we have created 29 criteria of the industries where people use credit card and compare the consumption between last year and this year, before and after COVID-19. So we are working on these data in collaboration with third parties, and we have some ambition and high interest to collaborate further. So I believe you are on the same page, Dr. Anda. So maybe if you need some research material, we would like to, and we're happy to provide some information to you, Dr. Anda. But I have one question here.
이런 어떤 그 핸드폰이
about mobile devices as urban sensor provider, and this is highly relies on the telecommunication companies, and there are some GPS issues that you may pay attention for better management. And is there any parts that you specifically specifically paying more attention to make up for that difficulties and obstacles of using these GPS data?
Yeah, thank you very much. I think, yeah, indeed, it is a possibility to do a collaboration. Like similar to these issues you were raising about being able to have some analysis on tourism and do the differentiation between people that are visiting, for example, and residents. We have already do a similar collaboration with the Australian Tourism Research Board. This is exactly what they are like interested on. Like they want to see first some insights about the people, like the visitors that are currently in Australia throughout the months, throughout the years. And we also provide some real-time data to them, so they can actually locate in every neighborhood area in Australia and see how many people are tourists, where do they come, and then of course like this can be analyzed into different categories, like where do they come from, how long have they been staying there, and then you can, and then at least here in Australia, it's important to them to have some indicators of tourism in their country, and also to plan better infrastructure for especially in cities where there's like always a lot of tourists. So we have a similar ongoing collaboration with the Tourism Research Board in Australia. So I think like we can happily discuss later about what is actually like your needs, or what would you be required to, but we already have some experience there. About the question that what would be like the more specific thing, or the thing that we put more attention to when dealing with mobile phone data, so or GPS data, what we process the most is mobile phone data, right? We have some GPS data sets. Those GPS data sets are an auxiliary data set for us because they are not, they don't have these temporal observations, like large temporal observations. It's just some GPS points at certain times of the day. So we use it as an auxiliary way to enhance the spatial accuracy of mobile phone data, which we have 24/7 because it's already collected in the telco network. So this is exactly one of the things we pay more attention to the spatial accuracy. Also because there is sometimes a misunderstanding when people listen to mobile phone data and then see that these trajectories of people can be derived. Many people think of or have expectations similar to what GPS data delivers, right? So, but there is a clear spatial accuracy difference. GPS data, it's between 10, 50 meters. Mobile phone data, normally it comes from how dense is your network of cell towers deployed in the city. Part of what we do in Data Spark, and part of what has been done, the research effort in academia, is how can you enhance further that spatial accuracy? And it's not because it's not useful at that level. At that level, actually, it's very useful when you want to look into, for example, trips in a city, when the resolutions are similar to the cell towers deployed, and you can easily see how, like, the origin and destination of trips. You might not be able to pinpoint what's the exactly building, but you have a good understanding of what's the neighborhood. Sometimes for some applications, it is required more resolution. For example, sometimes in Singapore planning agencies or transport agencies, they want to look into the last mile problem, meaning like once they alight from the MRT or the bus, what is exactly the final destination? So for that, they require sometimes more granular data. So part of the efforts we do is actually how to use, for example, the GPS data, how to use like some properties from how the telco antennas are deployed. There is some angle in which they're deployed. There are some also some signal related to the power. for example, when your phone connects to the cell antenna, there is like a power level. So there are many things that we are using to improve this spatial accuracy. That this is one of the points that we take more attention to. The other part we paid a lot of attention to is to be inside the data privacy regulations. Sometimes is whenever this data is used inside the telco, it's more free, right? It can be freely used to improve the planning process of how the telco deploys, for example, the upcoming 5G network. But when you want to use this data for something that is outside of the reason that it was collected, then there is the privacy issue, which is very understandable, and that also has had like a lot of attention in the public eye in the last couple of years. So then whenever we, for example, have collaboration with academia, this is one of the main challenges we need. Like, even if it's academia, we cannot provide data that they might be able to re-identify who is the person behind the digital trace. So we need to provide data in a way that we ensure that there's no way to identify people from these mobility traces. The applications that we currently provide to agencies are also, they go along also with these privacy regulations. We give counts of how many trips have emerged from certain origin to certain destination, but we never give, for example, individual level data. So I think that would be the two main attention points we have. One on the technical aspect, which is the ways in which we enhance spatial accuracy in telco data, and the other one more on the practical implementation and the regulations on how to make this data useful outside of the telco, but without having some risk of privacy problems.
감사합니다.
Thank you.
오늘 토론을
Today, having panel discussion with the speakers and discussant, we are about to wrap up. Upon listening all of your discussion, I realized that sensing what is happening within the cities, that is happening around the world, and the data that we gather from the sensors, we need to make most of that academically or policy making wise. I think we are about to launch a long journey of utilizing those gathered data. Also, the mobile phones that every single human being carries every day, we can also gather the data, and then we can definitely extract data and use that in a meaningful way. So those are the major trends. Within the area that you're responsible for, I believe we need to make sure that the accuracy of the sensor must be secured, and also the locations of the installations of the sensor must be made sure. And also, in utilizing the mobile phones gathered data, we need to make sure that the privacy needs to be protected. And also, there are issues of the privacy as well as other laws and regulation. Well, listening to the presentation and also the discussion, different ideas popped up in my mind. What I can say is that academically, I've never been so excited like today. This is a rare chance that I feel my heart is sleeping, and I feel like going back to my company or my institute and then write down the plans to do the research. I'm so excited, and thank you for giving that kind of inspirational message. The 2020 is a very unprecedented year. We don't know how it went by. I mean, time really flew because of the COVID-19, but some say that lest we remember, we feel that time really flies. So we don't have any unique things that really sort of traumatize us that we can remember forever. That is why we feel like the time really flew this year. And I hope that next year it will be much better. All the participants joining us via YouTube and also physically participating people, maybe today could be something that you can remember as an impressive thing.
분들이 올려주셨던
And
질문이
there were a lot of questions uploaded on the YouTube, the trading box, but I believe those questions were addressed, so I wouldn't be reading those questions.
세계 각곳에서
And once again, thank you all the participants joining us virtually and physically.
오늘 이런 귀한
And
시간을 갖게
thank you once again, the speakers, for a great presentation and also discussant.
이것으로
We will now wrap up
네 번째 세션
the fourth session addressing the urban sensor network. Thank you everyone for the presentation once again and also the panel discussion. Thank you.
Thank you.
Thank you very much.
Thank you very much.
Thank you very much.
네, 안녕하십니까.
Good afternoon.
맛있게 드셨나요?
I hope you enjoyed
두 번째
lunch.
날
We are in session 5 on day 2 of
이게 벌써 다섯
Seoul Big
번째
Data Forum.
세션이거든요.
This is the 5th session
저는
of the entire
서울시립대학교
forum.
공간정보공학과
My name is
임평
Im
교수입니다.
Pyong, a professor from Seoul
영광스럽게도
University
이번
of
세션에
Seoul. It is
가장
my
맡게
honor
되었습니다.
to be
제가
with you
저희
as a
학교에서
moderator of
그
this session.
빅데이터 AI 연구소
I am-
AI 복잡계 연구센터도
I'm the director of the Research Center for AI and Big Data at the University of Seoul.
주도적으로
This session is hosted by my university.
그래서 뭐 이번 발표도 하시고 또 저희
And
센터에서
we have some
토의도 함께 참여하고
professors with me from our university who will serve as a speaker for this session. I would like to tell you about
간단하게 소개를 하고
the
있는데요.
composition
뭐
of this
소개가
session.
끝나면
After this session,
국내에서 네 분의 그
we will
전문가
have
발표가 이어지도록
Sorry,
하겠습니다.
during this session, we will have 4 speakers. They will spend 20 minutes each to present their materials, followed by 1 hour panel discussion
함께 참여하실 패널
with panel discussants who will be on the podium later on. So a total of 6 will be involved in the panel discussion.
첫 번째 강사를 소개.
Let me introduce the first speaker of the session, and he's very famous and world-renowned. He's far away from us. He's in London, and we are going to meet him through the pre-recorded video.
진행될 예정입니다. 자, 런던 대학에 계시고요.
Let me introduce Emeritus Professor from University College of London, UK. His CV is too long for me to introduce in a short period of time. First of all, he studied in Cambridge University.
UCL에서 교통
Also in UCLA, he majored in transportation science, and he did a lot of research regarding transportation, and he has great achievement in the area, and he's now emeritus professor in the University College of London. And I was told right before the session, I was told that he's advisor of one of the speakers today.
런던 대학 유니버시티 컬리지 런던
Once again, let me introduce Emeritus Professor Benjamin Heidecker.
강연을 듣도록 하겠습니다. 강연 제목은
The topic is Evaluation of the London Ultra-Low Emissions Zone Using Incomplete Big Data.
Hello and greetings from London. This is Ben Heidecker, Emeritus Professor of Transport Studies at UCL. I'm delighted to be joining the 2020 Seoul Big Data Forum, even if I can't be with you in person this year. So today I would like to tell you about how we used big data to assess the effects of a transport intervention in London, the London ultra-low emissions zone, and some of the challenges that arose partly because of tackling big data, using big data for the investigation, when big data sometimes aren't enough on their own, and also, of course, the effects of the COVID-19 pandemic that influenced the evaluation, as we will see. So without further ado, I will share my screen, and this is This is work that I undertook jointly with our recent doctoral graduate, Dr. Hajar Haj Mohammadi. It was sponsored by the Lloyd's Register Foundation, and we're grateful to them for their support for our work. So we're interested in analysing the effects on air quality of the Mayor of London's intervention that restricted free access to the heart of London to vehicles that comply with good emission standards. So we'll look to see the effect that had where it was applied, but also more widely across London. The concept is that we would use data from many sensors across London, each reporting every hour throughout the year, and we'd take 1 year before implementation and match it with 1 year afterwards. But the facts are that there were gaps in the data, and of course, COVID-2019 disrupted normal traffic, and that will affect the data that we receive. So the background, central London has high levels of pollutions, and the map on the right of the screen shows nitrogen dioxide concentrations as measured in 2016. And from this, you can see the major roads, the orbital roads around London, and also in the heart of London, there is this high level of pollution in NO2, but also the other oxides of nitrogen. So we were concerned about those, and we want to, the Mayor of London wanted to intervene in a way that would improve air quality towards international standards. So the idea was that in the very heart of London, this light shaded area, the ultra low emission zone would be introduced. And it's a daily charge for any older vehicle that is pre-Euro standard and various standards, Euro 4 for petrol, 6 for diesel cars, vans, and 6 for lorries, buses and coaches. It was introduced on the 8th of April 2019. This area in the middle covers just 22 square kilometres, and that is the same as the congestion charging zone. So that's very convenient. Cars that comply don't have to pay, so it's only an incentive, it's not a complete ban. In October 2021, as the plan goes, the ultra low emission zone will be extended to the extended zone, which is roughly 250 square kilometres around the middle of London, and that is bounded by the north and the south circular road, so it's landmarked in the road network. What we wanted to do in this study was to evaluate the effect of the ultra low emission zone, but looking across the whole of London. So the abbreviations I will use today are ULEZ for the ultra low emission zone as implemented, UXZ for the ultra low emission zone extension that hasn't yet happened, but we have some sensors in this area, and then GL for Greater London. We have some sensors further out, distant from where the intervention took place, but perhaps affected. So the study concept was we would take the date of implementation at the beginning of April 2019. We'd look at 1 year's data beforehand, so that's April 2018 to March 2019, and 1 year after, April 2019 to March 2020. And of course, when we set up the study, we had no idea what was coming. We expect to see benefits from the reduced flow of non-compliant vehicles, and of course, reduced flow in the ultra-low emission zone. We also expect to see some potential users of non-compliant vehicles switching to compliant vehicles. So we expected there to be an increase in compliant vehicles, even though there was a decrease in non-compliant. That's within the zone. But the effects are going to spread across London because of various things. One is the pollutants don't remain where they're emitted. They will spread through the air. And also, the traffic that generates the pollutants will travel outside, usually travel outside the ultra-low emission zone as well. Now, the lower emissions vehicles that are compliant will have lower emissions outside the ultra-low, and if there's been a switch to compliant vehicles, we'd expect a reduction in pollution outside the zone as effect of that. But there's also another possibility, which is that non-compliant vehicles divert around the ultra-low emission zone and travel further than they would otherwise have done, and somehow confer disbenefits beyond the ultra-low emission zone. So we don't know until we do the measurements, and we'll have to find out. Of course, the original concept wasn't possible because COVID-19 had effects, and in particular, during February, traffic levels were already falling in London because of reduced personal activity in the heart of London. And by March, the government had introduced lockdown measures that meant there was very little, if any, traffic in London. So the months of February and March 2020 were affected not only by the ultra-low emission zone, but also by the COVID restrictions. And that meant we couldn't compare between those months and the two corresponding months before, and only see a difference due to the ULEZ. So we couldn't include those months, and all of a sudden our planned, carefully matched comparison before and after fell by the wayside. It's just not possible to do a before-after matched in that way. The data we have got, well, the original design was to measure three pollutants: nitrogen oxide, nitrogen dioxide, which is the most hazardous of the oxides, and then the combined NOx. We have measurements of each of these three pollutants at 28 sites, and 11 of them are actually within the ultra-low emission zone. A further 9 are within what will become the extension zone, and we have 8 outside that in Greater London. So with 24-hourly observations at 28 stations, 3 pollutants, 365 days of the year and 2 years, that gives about 1.47 million observations. Looks like lots of data. That's great. But then, after we've removed 2 months, February and March 2020, because of COVID-19, that leaves us only 304 days after implementation. Now, it's a reduction in a large number of observations, but February and March are not typical months. In fact, there are no really typical months of the year for pollution. So all of a sudden, we've got an unbalanced data structure. That left us 1.33 million possible observations, of which we only had 1.26 million real data, and there were 75,004 missing observations for various reasons, detector outage and the like. So we're going to have to deal with that. But when we think about variations in pollution, there are several different causes. And we think about spatio-temporal correlations. The temporal correlations happen because the previous levels of pollution will persist at each site. So what happened at a certain hour will depend to a certain extent on what happened the hour before. And that's something we need to take into account. But also there's airflow from nearby locations, which will give rise to lagged spatial correlation. So we've got serial structure and we've got spatial structure in the data. The temporal variations on a longer time scale happen because of months affecting the traffic flow, and also a temporal trend in traffic flow. We see decreasing numbers of private vehicles entering central London. We think this is a good thing for traffic management, but we understand a long-term trend like that will have influences in pollution levels over the 2-year time frame of this study. So we need to account for what would have happened in any case. Then there's the weather, which varies from month to month, and something else is going on. The vehicle fleet is being improved, moving away from non-compliant vehicles, pre-Euro 4 or Euro 6, up to more compliant vehicles. That's happening anyway as the fleet changes, and that will affect the emissions. And that will be going on anyway as well. Okay. Then on top of that, there's the bit that we do want to know about, the bit we want to separate, the effect of the introduction of the ultra-low emission zone charges. That will affect the flows, reduce the flow, and also affect the composition of traffic that is on the network. Okay, so the methodology we adopted is called MARS, Multivariate Autoregressive State Space Model. Quite recent. It's a vector time series model, and it allows for spatiotemporal processes. The vector part allows us to use data from different locations, and the time series part allows us to use lagged observations as well. We have 3 separate models, one for each pollutant, and we're representing the pollutants by X, but they're observed inexactly. So we've got a possible error, epsilon, in observation. We allow for observation error. We've got the measurements Y, and we use those as information. And the model itself allows for serial correlation at each site, and also correlations, spatial correlations across sites. So the state X at time t depends on the state across the whole network at time t minus 1, according to the linear combination represented by the matrix B. We have monthly effects, one for each month over the 12 months, and we switch the right month in using this indicator. And the part we really want to know about is the intervention effect, measured by C, and that is switched in at the time of intervention, TI. And there's some error in the process matrix as well. So we want to fit this model and estimate the value C from it. M is a monthly effect to allow for all of weather and traffic, and because of the structure of the model, it absorbs any constant, any trend over time, and the 2 months that aren't matched will be represented separately by their month effects. And by doing that, they won't affect our estimate of the intervention effect. And C is what we want to estimate. So the data incompleteness happen in 2 reasons. The first is February-March 2020 cannot ever be matched to corresponding months before ULEZ. And that's never going to be possible. We have to deal with it. So what we're going to do is we're going to base our comparison on the 10 months, April to January, and do a before-after for that. But then we've got these 75,000 observations missing due to various reasons. And we adopted the mice method to complete the time series. And we can certainly recommend that. We need a complete time series in order to achieve data sufficient for time series analysis. The results. Well, these results are shaded according to the zone. They're ranked from biggest intervention effect down to smallest for each of nitrogen oxide, nitrogen dioxide, and combined NOx over here. So we can see that the ultra low emission zone had greatest presence, greatest influence, as we would expect. Interestingly, not so predominant in the NOx, excuse me, the NO2. And this, putting that onto a heat map, we can see for each of the stations a darker color indicating the greatest effect. And although there were strong effects in the ultra-low emission zone, also there were substantial effects way beyond it at stations we had. And in summary, the average reductions clearly strongest in the ULEZ for each of the pollutants, and especially nitrogen oxide, and less variable for nitrogen dioxide. So some large effects beyond the ultra low emission zone, and that's interesting. When we look at the correlations, the serial correlations, we find that those are weakest in the ultra low emission zone. So an observation in the ultra low emission zone for nitrogen oxide typically is about 70% of the previous hours, plus correction for months. In Greater London, the outer observations is about 90% dependent. So we see the strength of the serial correlation increasing as we move away from central London. The cross correlation, the spatial effect, so BRS are different, we see these moving in the opposite direction. And they're weaker than the serial correlations at each station. So the spatial influences are greatest in the ultra-low zone, and the spacing between stations increases as we move away. That's a geographic fact. So we see the influences decrease. The monthly effects, well, the seasonal effects, we see a strong seasonal effect for each of the three pollutants. So it was important to include this in the model in case the emission of 2 months affected our estimate of C. And we see this because the effect of COVID-19 was to remove from the estimation process these 2 months, leaving only the others. And certainly those 2 months were not typical of the whole year. So why did we need to include February, March 2019 at all? Well, the data required for continuity of the time series, without which the time series analysis won't apply. So we left the months in, but we didn't include them in the evaluation. So conclusions. The ultra-low emission zone reduced atmospheric pollution below trend. All our estimates of C allow for what would have happened, our estimate of what would have happened if there hadn't been the intervention. The benefits extend beyond the zone of implementation. This is very good news. So that we suppose is because of traffic flows, fleet competition, and indeed spread of pollution. For methodology, well, we needed a monthly seasonal analysis. We needed that anyway, but that had the effect of overcoming the incomplete after year. And of course, there is a slight reservation that the results strictly only apply to 10 months of the year. We have no reason to suppose that the effects would have been substantially different in the 2 months that we couldn't include. But we weren't able to do that evaluation, and we never will be. The spatio-temporal analysis that we adopted respects the physics of pollution, the spatial spread of both the pollution and its causes. And so far as the time series approach is concerned, which was necessary because of the autocorrelation, because of that, we needed to complete the time series, and we did that infilling using the imputation method, the mice method. So in the end, our conclusion is even big data might not be sufficient for every application. And we have to consider how best to use big data. So thank you for your attention. And I wish you a successful meeting and look forward to engaging in the discussion. So good day to you.
네, 감사드립니다. 저 멀리 영국에 계시는 그 벤자민 하이데커
Thank you, Professor Benjamin Heidecker. It was a very good
맑은 공기를
presentation. Air, clean air, and all the country's effort are the common issues that we have, I believe, after listening to Professor Heidecker's presentation. The second presentation will be delivered by Professor Lee Seung-jae of University of Seoul.
저희 도시과학 빅데이터 연구소에 빅데이터 공동
At our big data lab, he also served as the head of our lab and has been working for more than 20 years. And he is specialized in urban planning and also using AI and big data. He has come up with a very significant and meaningful research. The title of today's presentation is, which is very suitable to our daily lives because we are all suffering from COVID-19. He will talk about revealing safer ways of public transport use with COVID based on big data analytics.
요즘에 꼭 필요한 내용.
I guess this is exactly what we need.
Okay, thank you, Professor Im Pyong-lee. I present revealing safer ways of public transport use with COVID based on big data analytics. We have found how to travel in public transport based on the big data analysis, and then that is a kind of the good guideline to use it. So outline of the presentation is current status of new coronavirus. Particularly today, Korea hit a very strong peak of the corona virus spreading. So we can see what is the time series data of the virus spreading. And second part, I would like to introduce the respiratory infectious disease monitoring and prediction system. We have developed it based on the big data, and then particularly for based on the smart card data, and then that lead to give us some kind of the guideline how to use public transport amid COVID virus. And third part is a kind of the guideline that is combined with the big data analytics, so revealing safer ways of public transport use with COVID. The first one is if somebody maybe feel some symptom like a cough or fever, and they should not travel if somebody has such a symptom. But actually, people may not know whether he or she really infected by the virus. So we have developed the app in the mobile phone, and then check whether he or her the timeline of the previous maybe 1 month, the course of the public transport may be affected exposure of the virus. So according to the use of the app, and then they know exactly how they may be exposed in the virus. And then that can be very helpful to judge whether they have to make a decision to travel. Second is wearing a proper face mask is very important, because the mask effect is quite good, because we have collaborating with Korea Chemistry Lab, Dr. Lee Gyu-hong, and then he experimented on disinfection effect of the mask, particularly KF94. That is quite effective, so I'll show the results of the experiment. And third one is actually keep social distancing is quite important for traveling, particularly overcrowded public transport. So we also developed the app to use en route routes to avoid such overcrowded the part of the public transport. So repeatedly use the public transport section if somebody feels unsafe. And fourth part is plan somebody's journey to minimize the risk of exposure. This is also the app that is particularly before the departing of the trip. So pre-trip cases, they know which way or which route is maybe safer to use in public transport. So first part is current status of new coronavirus. So this is time data. So we have around very big second wave actually. Currently, today, I heard from the news, around 300 persons are confirmed in Seoul case. So the peak is a very high peak. So we have to be very careful about that. And then we have find some relation between the coronavirus outbreak and the public transport use rate. We have compared the data 2019 to 2020 in some particular day. And then you can see around 44% has been reduced by comparison with 2019 and 2020. So particularly the public transport operator, the metro and the bus have suffered from such the revenue loss. So we have to find the safer way. And then we can generally compare between the 2019 data and 2020 data, and then you can see very big gaps after the coronavirus outbreak. And also we have some measure by government, social distancing rule, and that is a kind of regulation to use it. So we have a social distancing rule, phase 1, phase 2, and phase 3. According to such a regulation, and then maybe public transport use rate is quite reduced. But after that, there is a rebound effect, or resilient effect. So people use the public transport much more. So we can see some relationship of the coronavirus anti-measure and the public transport user rate. And then this is the respiratory infectious disease monitoring and prediction system. You can see in some movie how to the model coronavirus spreading process. This movie is made with some kind of the animation, and we have developed this system with some multimodal use and also activity-based model. And then I'm not sure this movie is played or not. Automatically it should be played, but it doesn't work, I think. Okay, yeah. So we have some multi-agent, and then they are actually quite different, and they have a different occupation, and also there is a different purpose of travel. And this is a Seoul area, and 24-hour simulation. So all the activity is generated during the Seoul area, and then after that, they are moving from their home to their workplaces or school. This is by car. So you can see some section is represented as red, and then represent some congestion. And also we also modeled the transit system. This is the whole the 9 lines of the Seoul area. So we have around 1 to 9 lines. And also you can see some the boxes are the green represent not many congested, but red represent congested. And also we model the bus. For example, number 420 bus that is moving from southern part of the Han River and the northern part of the Han River near our university, and then loading and unloading point represent. And also this is very important features, encounter network, because encounter network is the people meet each other while they are traveling in public transport. So this is a very key concept to estimating the infectious process of the public transport. And this is just some line 7, the example of the spreading, the simulation based on real data. And also this is line 5. So in different locations, their infectious, the power is different actually. So some, the peak time is much more influential, but the on-peak or weekend is less influential. So particularly overcrowded situation is very, very dangerous. So we have to be careful. So analytic framework is, there's a 3 components. First one is the big data. So we use so many big data, particularly smart car data and national health, the insurance data, and also modeling is methodology is activity-based modeling. So in particular, we are generating avatar because multi-agent the simulation model, we need some different characteristic of the passengers, and also we combine with the encounter network analysis, we need to the SEIR model, that is a kind of the model to know the infectious way. So we use this SEIR. And then we deliver the information to the users, passengers, and public transport operators, and maybe government. And then they may be doing something. So based on trip chain data, and then the encounter data network, because encounter network means in public transport user, every day they meet somebody. So their face is very familiar, so, but they are strangers. So they have forming a group. Somebody in the group is affected by the virus, and then they may be spreading to other familiar groups. So that is the key rule in this simulation. And also, we have lots of big data, particularly smart car data, and national health insurance data. And we have also mobile IoT sensor data to verification of the results. And also public transport timetable data, something like that. And this is based on the smart car data. We use the encounter network analysis. So identify familiar strangers forming process, daily repeated the uses of public transport on smart car data. This is an app we have developed. You can download it from Play Store called 교통 안전 지킴이. So we have 2 systems here. One is backcasting. So previous day, you can check whether you are affected during the past travel, particularly in the 1 month data. We store all the data since January, but recent data around 1 month ago is mostly updated. And then I think the movie is not working. So somebody in the backside should be play, actually. And also, you can indicating some date, previous day, and then check your timeline of data, and then they calculated what is the degree of exposure. And then forecasting also, you can just put your origin to destination, and then they recommending very safe ways. Yeah. Okay, this is SEIR model. The parameter we have applied is we are based on some MIT researchers' parameters, so we need some localization. But that is published in the science journal, so we just believe it, but we need localizing. So we have to collaborating with somebody in Korea working in this field. And also, this is predicting spreading area, is lines, and the area, and some section of the public transport. This is the guideline we obtained to safer ways of public transport use with COVID. First one is do not travel if you have a symptom, but you are not sure, so you can check, double check with the app you have developed, backtesting, and check how much you expose in the virus. And the second one is maybe that is not we are researching, but that is important. So before and after traveling, you have to sanitize your hands. And second one is also wearing a proper use of the mask, particularly in the KF94 is quite effective. You can show it later on, and also minimize touch point in public transport. That is also very important, but we didn't analyze it. Third part is keep social distancing by avoiding overcrowded public transport. So that is en route to the decision using the app. So I can show you further. And the fourth is plan your journey to minimize your risk of exposure. So you can check with the app whether the route is safe or not. And five is avoid face-to-face position in a compartment of PT. That is the low-tech, but it's very sensible way of avoiding the virus. So person is do not travel if you have a symptom, backtesting. Yeah? So we have a database, particularly in the last 1 month, data is enhanced, so you can check it. And this is the app I showed you before in the movie. And you can select data for backtesting, and then they calculating the exposure rate. This is the exposure rate calculating, so the degree of exposure. So if degree is very higher, and then you are dangerous, so you should maybe wait and then maybe go to the hospital to really check the COVID. And second is wearing a proper face mask. That is experiment on disinfection. So we have the experiment with the Dr. Lee in Korea chemistry lab. And then this is in the lab, they prepared experiment condition. So a 0.5 meter and 1 meter and 1.5 meter, 2 meter, and 3 meter, they spreading using some mannequin, and then they experiment how exposing the virus, and then with and without the mask. So this is two big results. One is the best case, the other is the worst case. But best case means is we can check droplet. droplet is usually we regard the droplet through the droplet somebody is infected. Yeah? So the inhaling, exhaling. So inhaling is quite low because it's bilateral, not unilateral. So mask should be wear all the people. So exhaling and inhaling process is checked. So and then based on this result, actually it's quite safe to travel public transport with the mask. And the worst case is we also the experiment on nano scale. So maybe aerosol, maybe. In the case, the nanoscale aerosol can be spreading. So in order to prevent such a case, we have to open the door regularly to ventilation, so the fresh airs. Yeah. So third is keep social distancing by avoiding overcrowded public transport within the dynamics, particularly en route cases. So this is the degree of the crowdedness for calculating encounter network. So based on this, the condition, we calculating the encounter network and then to calculating the exposure probability. And exposure calculation is based on the actually the congested state of the compartment, and so you can see the uncongested and congested the part differently, and also based on the different day and time and line. And also you can see the pathway of infectious person. So we show some section of the area. And this is encounter network analysis. You can see there are different conditions of the day, weekday and weekend day, and peak hour and non-peak hour. And also we compare. We need some movie here in the operator room because the movie is not working. In particular, the MERS case. We have conducted this research since 2015, actually, around 5 years ago when the MERS virus hit. So that is also encounter network in the MERS case. You can see in the MERS case, that is also very powerful. And you can see the super spreader. So according to big data rule, 2080 rules actually. So 20% of the bigger influencer of the virus is appeared. Fourth is plan your journey to minimize the risk of exposure. So between day dynamics, particularly pre-departure time. And this is also network configuration for safer way calculation. So based on this network, we also calculated the Pareto optimum. So somebody want to travel time minimization, somebody want to travel distance minimization, somebody want to use some facility like an elevator. So we can give us some option to calculate the data. And the information updated regularly, particularly from the Incheon airport or Gimpo airport, because overseas inflow can be influenced to the virus. And this is the app, and then they recommended a safer way of traveling. And also we have classification of data by synthetic population generation process based on the National Health Insurance Corporation data. But this is very vast, so we are just doing now by region and some by sex and some by age. And also we have some proof data system, particularly IoT mobile sensor, and then that catch the Wi-Fi data in the passengers. So route data and some kind of the other data we obtain automatically to send the main server and to calculate and then later to users. So generated the avatar based on the activity-based system and calculating the congestion and the exposure rate. and to deliver the information. And fifth one is avoid the face-to-face position in a compartment of public transport. This is a quite a low-tech technology, but it should be sensible, like this way. So sometimes we face very overcrowded situation, PT, so do not position face-to-face in case. So we have to different direction of the position is necessary. Another one is this is actually not low-tech, it's high-tech. Recently, the Seoul Metro government installed smart bus sheltering system against coronavirus. They have a good facility, purifying air conditioning system and surveillance system to check heat automatically. So this kind of the shelter, smart shelter, should be introduced in the future in the compartment of the public transport, particularly metro or bus. And then we can maybe feel safer, and then we can also travel safer way of traveling in public transport amid coronavirus. Thank you very much.
네, 이승재 교수님 수고 많으셨습니다.
Thank you very much, Professor Lee Seung-jae. You have revealed safer ways of public transport use of COVID-19 based big data analytics. Thank you for your analysis. We were able to learn how we could move from one place to another place by using this kind of methodology.
이따 또 패널 토의 시간에 저희가 각각
We will
발표에 대한 질문
discuss more of each point from each presentation later on in the panel discussion. If you have questions from each presentation, you may want to leave your question on the YouTube channel. Let me move on to the next presentation by, hold on,
서울대학교 환경대학교
Professor
학과에 계시는
Kim Tae-hyung of the Environment Engineering of Seoul National University. I would like to briefly explain about the professor's bio. In 2013, in Georgia Tech University, he achieved the PhD. And from 2018, he's been serving as a professor, visiting professor in Saudi Arabia, and now he is a professor at Seoul National University. The topic of his presentation is impacts of COVID-19 on multiple scales.
Thank you for your introduction, Professor. Actually, they asked me to send the file and the title, English title, and I think they incorrectly translated. It's not really about their scale or measurement scale, but their geographic scales. It's great to see you again. I'm Kim Tae-hyung. I'm Associate Professor of Environmental Planning at Seoul National University. And, well, actually this presentation file was made by me and four of my students. Their names are listed on the lower side of the slide. To be honest, this presentation is not really about big data, but actually it is more associated with COVID-19. And I was invited to give a talk by Professor Hee-jung Lee, the organizing committee chair. He is a PI for one of my two COVID-19 projects, and I will give an overview of the project. Okay, this is the flow of my presentation. First, I talk about the spread of COVID-19 according to three phases, and I show why this pandemic needs to be addressed on multiple scales: international, national, and metropolitan. Then, I give an introduction about the COVID-19 project. Third, a survey was conducted in 3 different cities across Asia, and I compare the outcomes. First, my team performed predictive modeling to evaluate the effectiveness of the social distancing policy in Korea. Finally, on a multiple scale or metropolitan scale, I show how COVID-19 affected the perceived risk and subsequently the transportation mode choice. There are three waves of the spread of COVID-19. Each is characterized by the global, national, and metropolitan transmission. The first wave occurred on a global scale. The virus spread from China into neighboring Asia and Western countries as highly connected. Then the virus was expanded from the Western countries as transportation hubs to the other parts of the world. Infection rates were high actually in European cities and urban areas because people living in the city have various and large networks when they work, shop, and play. So, if the virus is not eradicated, it will show up again at any time. The second wave occurred on a national scale. The left figure shows the first large-scale group transmission in Korea. A church congregation produced an explosive number of confirmed cases. Actually, in the West, such a group transmission was reported from bars, nightclubs, and parties. From the red circle focal point, which is Daegu, here, the virus spread into the neighboring province, Gyeongbuk, and then to the national capital, Seoul. Subsequently, as shown on the right, the virus transmitted between major cities and regional centers. The third wave is a transmission from regional center to local communities. The three waves are like a hub-spoke distribution system. First, the virus spreads from the epicenter to its neighboring areas and to hyper-connected transportation hubs and national centers. Second, it is distributed from the national centers to regional centers. Last, the regional centers become the source of the pandemic distribution. So, from the global to the regional scale, we need both wide angle and telephoto cameras to study the spread and control of COVID-19. It's not 10, but 19. Last summer, I embarked on an international cooperation project with funding from the National Research Foundation of Korea. The initial team consisted of me and 4 international scholars, as shown in the light blue boxes, the 2 boxes, on the right and on the left. 2 months later, I secured funding from Seoul National University and initiated another project by inviting 6 domestic researchers. So, the 2 projects are currently conducted by 11 professors and their students. This slide shows research goals on the 3 geographic scales and research content. So while the projects are still ongoing, I show the initial findings from the prediction modeling and the international survey. This is the breakdown of the project responsibilities by team. The project outcomes are shared in several different forms. First, I'm organizing a special session at the annual meeting of the WRSA and planning for after-conference publications. Also, I'm guest editing a special issue for the IJERPH, the Q1 SSCI journal. Lastly, our teams will present at the special virtual conference of the SPSD. Well, a survey was conducted in Seoul, Shanghai, and Taipei from September through October. And And in Seoul, a follow-up survey will be done with the same sample. The purpose was to understand how people respond to COVID-19, especially in urban areas. Okay, the first finding is people in the three cities thought the virus substantially affected daily lives. However, the effect size was different among the three cities. The effect was the largest in Shanghai, possibly because of its partial lockdown. You can see the measures in the table. And it was the smallest in Taipei since I think it is relatively free from the pandemic issue. Also, we asked about which characteristics are positive and negative in transmitting COVID-19. The most negative characteristic was high density in Shanghai and Taipei, as expected. But it was religious facilities in Korea. This may be because group transmissions were repeatedly reported from churches and religious facilities. One interesting result is having hospitals nearby was considered negatively in Shanghai, but positively in Seoul and Taipei. Overall, people negatively perceived built environment facilities. But some people had more negative perceptions than their Taipei counterpart. You can see the value differences. By contrast, both people positively perceived the natural environment. Bottom one. People's purchasing behavior was dramatically changed. They preferred online shopping to avoid physical contact. And it was more so in Seoul than in Taipei. An interesting point is that local stores became more preferred than before in Taipei, but not in Seoul. Here. Okay, as discussed by Professor Lee, Korea is currently implementing 5-level social distance policy, and it is arguably the most effective preventive measure, or among the most preventive policies and tools. So, from January 29 to June 30, Korea's social distancing policy was classified into 5 phases according to the policy intensity. So, I examined whether the policy intensity affected the control of COVID-19. To this purpose, I computed the reproduction number. I think you are now very familiar with the reproduction number. And also, I computed the time lag for each policy to take effect. Also, I predicted what would happen if each phase was extended and the policy intensity was unchanged. I've run an SIRD model, same model used by Professor Lee, and I used the Python package COV-SIR-FEE. It is a COVID-19 SIR modeling package. Specifically, I detected a time point and the COVID-19 trend changes, and also I predicted the reproduction number and effective cases at the point. On the left figure, the policy intensity is represented by the depth of the color. The blue line shows that on the right side of the figure, the number of infected cases rebounded due to a weaker social distancing policy. Officially, it is called distancing in daily life. And in the figure, it is the second column from the right. And as shown in the table, the reproduction number changed from 0.48 to 1.72. The bottom part of the figure shows 7 epidemic trends computed by the SIRD model. It shows that the time lag was about 2 weeks at early phases, but extended to 18 to 19 days later. Currently, the social distance policy in Korea is based on the 2-week standard, and maybe it needs to be reconsidered. This figure is the outcome of the prediction. It was calculated by extending the last 4 epidemic trends. The green line shows that if the weak policy at phase 4 was extended in time, infected cases would sharply increase. Now, Korea implemented 5-level social distance policy, 1, 1.5, 2, 2.5, and 3. According to this outcome, the policy will not be effective if the level is lower than 2. In Seoul, I investigated how people's visit to different facilities has affected their risk perception over time. And I used a retrospective question to measure the month-to-month perception variation, and the model was estimated with the feasible GLS. First, population density and pedestrian volume lower the perceived risk. It means when people are surrounded by those who walk around, eat, and drink, normally they will feel safe. So I think the crowd effect is at play. Also, as expected, older people and those who experienced COVID-19 perceived a higher risk. And while COVID-19 worsened the perceived risk, I investigated how it affected the transportation mode choice. It's kind of like a complex diagram, and it shows the initial model and tested. And my hypothesis was that if people become aware of COVID-19, here, then they will think preventive policies are important and public places are risky, here and here. And this perceived importance and perceived risk will make people consider that using public transit is risky here, and then altogether reduce their transit use. That's my hypothesis. It was social demographics was used for statistical control. The model fit was generally good, and my hypothesis was mostly accepted. However, first, the awareness of COVID-19 did not directly reduce the transit use. It had only indirect effect. Here. Also, the perceived risk of public transit originated only from the perceived risk of public places. Here. Okay. Okay, that's all, and thank you for listening. And I will receive some questions and comments later.
네, 감사드립니다.
Thank you, Professor Kim.
님이 그 코비드 확산이 다중축소
Regarding expansion of COVID-19, we just listened to Professor Kim's presentation, and let us have the last presentation by
그 Dr. 이딜 아이랄
Dr. 이딜 아이랄.
이시고요. 저희 그 서울시립대학교 도시공학과
She is
방문교수.
a visiting professor of University of Seoul.
아이랄 교수님 소개를 잠시 드리자면
Let me briefly introduce Dr. 이딜 아이랄. She's originally from Turkey,
터키 이스탄불 테크니컬
Istanbul Technical University, was where she studied in architecture in BA, and she also graduated from there with her master's degree, and later she moved to Spain to study further, maybe in history, urban history, I will say urban history. So she continued her study in Spain in urban history, and in 2018 she achieved a PhD degree, and then from 2019 she's been a visiting professor at University of Seoul.
지금 이제 오늘 발표하실 주제는
Today her topic is urban space after COVID-19.
발표를 해주시겠습니다.
Let us listen, Dr. İdil Ayrıl.
Introduction, Professor. Hello, I'm İdil Ayrıl from Turkey. And as we already mentioned, I'm working as a professor in University of Seoul. First of all, I would like to express my gratitude for being invited here as a speaker today on a subject that I'm very much interested in, actually, and trying to expand my knowledge about. So during the process of preparation for this study, we actually worked as a team, me, Professor Lee Hee-jung, and our colleagues from the university, and also our young researchers from Professor Lee's research lab. We worked on different ideas in order to rethink the future of Seoul based on the collected data, analysis, proposals to create a more sustainable and livable urban environment for the citizens of Seoul. So today, first, I'd like to present some of these urban challenges that we are facing at the beginning of a post-pandemic urban future and share some urban data that shows the dramatic changes before and after the pandemic and some viable solutions that would answer these challenges, and finally making some conclusions. So here are the objectives of this study: developing a physical and social framework of post-pandemic urban future, examining the challenges and changes in public space and daily life practices in Seoul, constructing an analysis through urban data in order to propose urban solutions for a healthy and green urban environment, and highlighting the importance of big data in answering urban challenges while adapting our cities for a livable and sustainable future. So COVID-19 pandemic has created uncertainty because it attacked at the heart of our urban realm and daily life. And the lesson it teaches us that we need to improve our planning system for the new normal. We may not be able to foresee the next epidemic, next disasters, but we can be prepared and make our cities resilient. Most of us have experienced a reduction in our effective density level. We are not connecting with other people or sharing common infrastructure. Some people are working remotely, not traveling anymore, and we reduced face-to-face contact. So we can call this is the era of the untagged. In a pandemic, busy urban centers are a big part of the problem, and the pandemic has lighted the inequality between people who have access to public green spaces versus people who live too far away from them. For example, these two images on the left side, they show the actual urban green spaces in London compared to the green spaces accessible by public, which actually demonstrates us the dramatic situation of urban space and the right to the city. Urban green spaces are the product of modern cities. The park has been a remedy to the rapid industrialization of the 19th century, overcrowding of urban populations, the gap between rich and poor, the leisure problems, the deterioration of sanitation and epidemics. And today, more than a century later, this effect of the park is being rediscovered. We need more communal spaces. Across the globe, cities have been closing off streets to give people more space, and we can see hints of what the pandemic-resilient cities of tomorrow might look like in the way that urban spaces are being repurposed right now. And 21st century has so far seen SARS, MERS, Ebola, bird flu, and now COVID-19. So we can ask, how might be the cities of tomorrow designed so that the outdoors doesn't become a dangerous zone and remains a habitable space? And how could be the threat of future pandemics reduced while creating more livable and sustainable cities by benefiting from big data? Seoul is a large global city with a long history. However, in line with economic development, it has become very dense with shortage of urban public spaces, especially in the central areas. By the unavoidable impact of COVID-19, Seoul has also been witnessing a lot of changes in the way the citizens use its urban realm. One of the most observed phenomena is the shift from the usage of indoor facilities due to high infection risks towards neighborhood parks and recreation spaces. So first, let's have a look what the data tells us. Transportation data shows us the dramatic change between March, April, May 2019 and 20 in terms of subway usage. By looking at the percentages here, we can see the difference on the left side. And the next graph on the right side also shows us the comparison of number of users in public transportation between 2019 and 20 on weekdays on the upper image, and below image shows the dramatic difference on the weekends, where we can observe an extreme decrease in public transportation usage. Also, by looking at Tarangi, the city bikes data, we see that the number, distance, and usage time of city bikes increased in general. March and April 2020, when the usage time was relatively short after Corona, the increase is generally more than 30% and relatively moving longer distances with bikes. While the portion of tickets was high for various festivals, such as Cherry Blossom Festival last year in May 2019, the users preferred city bikes as a means of transportation in their daily lives after Corona. And here on the left bottom side also we see the status of electric kickboard users data, which gives us a similar picture of personal mobility as well. And transportation data here highlights the need of reconsidering transport and mobility in our city. Population and public space data also reflect dramatic changes in daily activities. Status of floating population in 2020 highlights the increase in parks after COVID-19, with population movement rates decreasing approximately by 20% and even by 40% on the right upper side within 4 weeks following the start of the pandemic. The increase in number of visitors in national parks and mountains, on right below we can see the graph, reduction of population movement after COVID-19, and citizens preferring to stay at home or doing activities near home on right upper side shows us the dramatic changes in the usage of public space as well. And here we see two surveys based on citizens' predictions about post-corona period, which points out that most of the survey citizens expect a daily recovery of COVID-19 within 2 or 3 years, whereas 77% of them wish to access to public spaces within 10 minutes of walking distance instead of high-density facilities. Citizens look for ways to continue their daily life and recreational activities during the pandemic as well, which underlines the requirement of evenly distributed new public spaces. On the other hand, movement for accessing public spaces would create risks for spreading the virus, and considering the possibility of future lockdowns or restrictions, the solution comes by ensuring equal access to public green spaces. So, what if space from cars was reclaimed and given to residents? What if Seoul transformed its streets into green corridors? The new normal requires social distance and wider outdoor spaces for citizens to enjoy their daily life without restrictions of urban mobility. Therefore, Seoul may also be reimagined to adapt to post-pandemic future by creation of pedestrianized zones, more urban parks, overpasses, or low-lying green corridors, establishing a connection between green spaces in the city and giving vitality to the streets through walkability. And here we see 6 focuses and interventions based on the challenges and some target solutions. So related with risk and safety, we can talk about distribution of green spaces, a green space within 10-minute walking distance, and pedestrianized areas. In terms of public space for all, continuous pedestrian space with more public life, new pedestrian walkways and bridges. In terms of mobility, vehicle or pedestrian traffic partially taken underground, new traffic flows, parking lots redesigned as parks. In terms of contact, citizens reconnecting with the city, larger public spaces allowing social distancing, and contact between the dense city and the greenery. In terms of connection, connected green spaces, green corridors, underground and ground level interaction. And in terms of tactical urbanism, space reclaimed from cars given to citizens, pocket parks located in urban nodes, and new green paths based on pedestrian flows. And the study that we made focuses on downtown Seoul and Gangnam areas in the heart of the dense city with busy traffic, pollution, a high percentage of daily usage, and lack of green spaces. So the first step was to conduct a study that focused on the analysis of data that was collected and analyzing the connectivity within each district using the space syntax. By looking at the data, we can easily realize the lack of urban parks and green spaces in contrast with the dense pedestrian flows, which is visible through the heat maps based on pedestrian activity on left upper side. And space syntax connectivity level analysis and green network analysis also on the right side prove us the low connectivity within the zone as well as the lack of accessibility to the nearest green public spaces. So as we can see in space syntax connectivity level analysis graph, in which red color defines the highest connectivity and green is moderate, whereas the blue color is the lowest, most of the chosen area consists of streets and blocks with limited connectivity. Green network analysis in below also shows the areas which are located within a 250 meter or 500 meter distance from the nearest urban green space, which gives us the information on the lack of greenery by the majority of white zones, meaning that these areas are located even more than 500 meters from the nearest green space. Therefore, based on the data, the second step was to establish a project that will answer to the question of connectivity to the through public space. So the flow of users was studied to create potential efficient connectivity based on the space syntax results. And the space reclaimed from vehicle traffic was transformed to urban corridors with different layers such as walkways, bikeways, and recreational areas. Here in the master plan, we can observe three major axes, the purple lines, where the traffic is taken underground, which facilitates new pedestrianized green corridors on the ground level. We can also see the proposed green network, the dark green parts, based on the pedestrian activity which is connected with the existing green network and public spaces shown by the light green color. And the orange color circles are new open spaces and pocket parks to provide a more vivid streetscape. And as a reference, we can see some tactical urbanism applications already made in Barcelona, Montreal, Shanghai, and New York. And in addition to proposing new bus stops and bikeways for enhanced transportation that does not rely on private car usage, some pedestrian bridges were also proposed to provide a continuous pedestrian activity. So these are some images that we just foresee for the future of Gangnam. And same data collection and analysis was conducted for downtown Seoul, which again showed us the contrast between the high quantity of pedestrian flow versus urban parks and green spaces. And here we can see Chongno axis, the red axis, shows the highest connectivity level in the area according to the space syntax analysis, whereas most of the area shows us blue and green colors, signifying the limited connectivity within the streets and blocks. Similar to the case of Gangnam, when we look at the green network analysis or accessibility to the nearest urban park analysis on the left below, a highly remarkable amount of white zones inform us that these areas are located even more than 500 meters from the nearest green space. Based on the connectivity analysis, the area between Cheonggyecheon, shown as number 1 here, and Taegero, number 6, was divided into two sections on both sides of a main vertical axis, Seoul Plaza, shown here as number 2. So western section with low connectivity, giving the possibility of creating blocks without vehicle traffic inside to reclaim space for pedestrians and bikes, as well as pocket parks, and eastern section where existing buildings and abundant facilities facilities can be rethought by creation of rooftop gardens, vertical gardens, and overpasses for pedestrians and bikes, as we see in the below reference images. An underutilized ground floor of Seoul Plaza can be also considered for greenery and bikeways to create continuation towards the horizontal axis of Taegero, which is also a pedestrian-friendly reconstruction project. Another very important horizontal axis, shown here as number 4, underground Uljiro, can be reimagined as a green walkway for pedestrians, as well as creating new openings and connections with the surrounding buildings, like we see on the left upper side, some case studies from Spain and Finland, and a low-line Seoul project, like in low-line of New York, like left bottom. And show as number 3 here, a training center since Joseon Dynasty, which was opened as a public park recently, could be also extended as a larger green space and an urban park. And finally, number 5 is an overpass tube tunnel for pedestrians, which starts from Seoul Plaza and extends until DDP on the right side and the urban park, shown as number 3, not only providing connectivity for pedestrian flows, but also giving the opportunity to enjoy the views of future public spaces, rooftop gardens, and downtown Seoul, like another Seoul project of our city. So in summary, the concept is inspired from observations of new types of adaptation and usage of public space. And it presents a new model of Seoul focused on decentralization, connectivity, and special democracy, a study that proposes a new way to dwell in the public space of Seoul based on the information extracted from data analysis. And here are some images that show how we imagined also downtown Seoul for the future. So as a conclusion, we need to create more opportunities to enjoy nature and make sure our cities become greener as they grow denser. And public spaces and planning of green space are fundamentals of future urban planning. If we know when, where, and what people are doing in the cities, a real picture of the dynamics of a city can begin. When visible information becomes visible through analyzing the urban data, we can have a better understanding of our cities, their functions, dynamics, citizens and their lifestyles, mobility and leisure patterns, and the interaction between people and the built environment. Of course, we should remember that there are other challenges, such as making our cities smarter, eco-friendly, a future perspective on clean energy, becoming zero carbon, environment, waste management, solving problems related with housing, air pollution, and of course, the climate crisis. Thus, the aim here is threefold: creating a well-planned compact city with shorter commute times, cleaner air, reduced noise, designing walkable urban neighborhoods that lead to better health outcomes and increased resiliency, providing access to public green spaces for all as a lesson highlighted by the COVID-19 pandemic. And the way to a healthier and livable urban environment goes hand in hand with the technology, big data, and smart cities. Thank you very much.
네, 감사합니다. 그 코로나
Thank you very much. After COVID-19, our urban space is required to drastically change, and it was a good overview. And I was very surprised because I don't think she's been in Seoul longer than I have been, but she had a better understanding of structure of a Seoul. So we just finished all 4 presentations. After rearranging the podium, we will soon begin the panel discussion. Later, I will see you again.
제가 그 시간적으로 3시에 시작하는 거.
I was told that we can start our panel discussion starting at 3 o'clock, but we have other presenters online, so let us just begin right away.
패널 디스커션을 어떤 방식으로
How do we do this panel discussion? We didn't have discussion to decide the way, but because we had a 20-minute each of the presentation, maybe each presenters probably want to add a little more, that they wish that they could present more within their limited presentation time. So probably we will go from
벤자민 하이데커 교수님
Professor Benjamin Heidecker. Hello.
Are you there?
Hello, and good afternoon to you from London. Yes, thank you. It was very interesting to see the different approaches to analysis of travel behavior in light of COVID. And of course, in our analysis, we were focusing on a transport management intervention, the ultra-low emission zone. In future months, we will be able to compare the effect of COVID through travel patterns on air quality in London using the same methodology, but with a second intervention from round about February 2020, when the effect of COVID on travel started to influence traffic in London, and hence the air quality in London. So very, very interesting to see how out of the pandemic we can see how much air quality in urban areas could be improved if we managed traffic down, if we changed human behavior, if we shortened commuting journeys, as we heard in the last presentation, how much difference that would make to urban air quality, which of course is a public health priority that will continue even after we sort out COVID. So thank you. Very interesting combination of presentations.
네, 감사합니다. Thank you.
Thank you.
지금 보니까 패널
Okay, now we have two panel discussants connected online other than four presenters. So before we listen to other speakers, I would like to introduce the two panel discussants, and maybe we will listen to these panelists first. I didn't ask to prepare anything, but I'm sure these professors are ready to go. First, Professor Park In-gyu from Seoul, University of Seoul. He is a professor in physics in our university. I'm not sure about his bio, but he can introduce himself shortly before he started. He's also involved in the big data and the urban planning, and he's actually the director of the Big Data Institute of the University of Seoul, and we have a lot of applied research and in terms of urban studies, and we have a lot of professors from applied areas, and maybe including AI, electronic engineering, and they are discussing how effectively and efficiently utilize the data. And we have lots of prominent workers at the institute. So first, I would like to introduce the Professor Park In-gyu, and I would like to give my microphone to Professor Park In-gyu. Can you hear me well? Yes, very clear. I was very surprised because I've never experienced this interpretation service, and I thought this is like an automatic service by the machine. And I fully enjoy Professor Benjamin Heidecker's presentation thanks to the interpretation. And also, Professor Kim Tae-hyung presented his presentation in English, but thanks to this development of technology, I fully enjoy the interpretation service and this technology on this platform. Probably I shouldn't call it's a benefit from COVID-19. However, due to COVID-19, we go beyond the spatial and temporal barriers, and we also go beyond the language barrier. I'm fully enjoying this session, and my major is not urban science. I'm in physics, and I usually talk about particles, and in the area of particles, we've been talking about big data for a long time period, and then usually we created the data through the accelerator, and then we somehow have the advanced technology regarding big data in physics. So rather than the other natural science data, we're more interested in the modern science, urban science data. data. And as my university established this Institute of Urban Science, and I greatly joined all the professors of the speakers. Thank you very much for the wonderful presentations. I actually took notes from your presentation. I will later deliver my questions to you.
너무 감사합니다.
Thank you very much.
그다음에 그 두 번째
Next, I would like to introduce.
소개해드리겠습니다. 저 잘 들리시죠?
Can you hear me well?
이재승 교수님.
Professor Lee Jae-seung? Yes, nice and clear.
이재승 교수님은 현재
Professor Lee Jae-seung is currently working at the Seoul National University,
MIT에서 그 계획 플래닝
majored urban planning at MIT, received PhD degree, and currently working at the Department of Landscape and GIS application and planning are his specialties. So some of his specialty overlaps with mine. Urban planning, urban designs are his major specialty as well. So could you please go ahead and make comment? I'm very pleased to meet you. My name is Jae-seung Lee. I work at Seoul National University at the Environmental Department. Thank you very much for the presentation. It was very interesting, all the presentation. The format of today's meeting is also very familiar. It's a hybrid model, online and offline. And being able to meet everyone together like this and being able to listen to diverse presentation was quite exciting. And thank you all for speakers. Well, upon listening the presentation by 4 speakers, I began to think about the meaning of big data. The issue of the big data has emerged only recently, but we are now even using big data for policy making and also for various reasons. And big data utilization is very much activated in various ways. And once again, what I can say is that I was very impressed with the presentation by 4 speakers, and I do have a lot of questions that I'd like to pose. So I do have a high expectation on the panel discussion, which is coming soon. Thank you.
네, 감사합니다. 네.
Thank you, Professor Lee.
이렇게 다양한 전공의 교수님들
We're gathered with various professors in different and various areas. As mentioned, let's just have a free discussion. If you're the speakers, maybe you can add more onto what you already presented, or if you have a question, just let us know if you want to go ahead first, and I will just, as a moderator, somehow maybe the outsider, I'll just oversee. And first, maybe Professor Lee Jae-seung.
Can you hear me? I really appreciate you can join this meeting. Actually, I checked the time in UK. It's a very early morning, around 6 a.m. Yeah, I am very, actually, I feel very sorry for you. Okay, my presentation is based on the actual big data and also national insurance data, and then we are connecting data real time, our database system, because we have to implement such a system in one of the small venture company. One of my PhD students established recently, around 1 year ago, and then he and our lab have developed such a system, and then we are monitoring, and then we making an app. But still, we need to lots of progress to develop further or in detail. So after this maybe discussion, we can maybe implement it further, reflected on your maybe very good comment. Yeah. Maybe if you have a question, and then I can happy to answer it. Thank you.
거기에 편하게 말씀하셔도 되는데.
I said you can feel free to jump in. I'm not sure anybody has any questions to each other.
제가 질문을 좀 드리고 싶은 게 있는데요. 이승재 교수님.
I have a question to you, Professor Isungdae. Professor Isungdae, your presentation is very important, very interesting, and I believe your observation is quite meaningful.
어려운 점도 좀
However, I bet that you had a lot of difficulties, right? How did you tide over those challenges?
앱을 통해서
You create application and you try to provide or reveal safer ways to the public, right? But when you gather those data could be quite sensitive, so there could be some privacy protection issues. And also, how soon do you update all these data as well as providing this information? Didn't you have any difficulties with the privacy issues? How did you overcome that? So can you elaborate that?
한국말로 해야 되나요? 영어로?
May I speak in Korean or in English? What should I do? Simultaneous translation is provided, so please allow me to speak in Korean, since I have to talk in a very specific ways. We gather real-time data from the Central Disease Prevention Agency, and it is extremely difficult, frankly speaking, to gather those data, and not every single data is gathered on a real-time basis. But 10 years ago, we have already worked with Professor Kayakson web app that we have developed with a foreign company, and 24 hours a day, 10 million Seoul citizens movement. We have done simulation, and actually they are all avatar, and each individual characteristic of the 10 million avatar, we write down their movement data, and CDC in Korea, and also Korean insurance agency, we gather the data. It's an ongoing basis, and within a very small lab, and using this 10 million avatar, we input all the data, but we don't need every single data because we represent all the important features of the data via avatar, so it's well represented, and it's a multi-agent simulation. So based on the big data rules, some of the information could be different, but as long as we have an average information, we can easily do this simulation. So on average, it's quite suitable, or it works well. Another important thing is familiar stranger was the concept that I have briefly touched upon. And people who ride public transport every day at the same time, at the same location, they ride the public transport. And there are people that they frequently passes by. So very familiar but strangers. They don't know each other, but they always meet on the same day. So we call these people as a familiar stranger. And through smart data analytics, we were able to identify that. From 2050, we have already done that because at the time we had a MERS, and sometimes we're able to identify super spreader because there are certain super spreader who moves around a lot, who keep spreading this virus, and once these people goes to a certain place at wrong time, it can spread widely the virus, and influence is detrimental. And these people, the super spreader, you know the 20-80 rule. So we have this 20% of the bigger and 80% becomes smaller. These data are all big data, and 20% of super spreader and second super spreader we keep having on. And we thought it would be great if we can grab them, and then we come up with a ways to grapple them. But you know that facial mask is extremely important. It plays pivotal role in stopping the spread of the COVID-19. You know, the droplet, we sometimes comes from our mouth or nose, and sometimes we breathe. It's an interactive one. Dr. Lee Kyung from the chemistry lab, he's very famous and knowledgeable, renowned person. And remember, we had this humidifier issues in Korea. He was the one who identified the issues with the humidifier, and scientifically it was proven, but the research result was not widely known. Well, and Anyway, we've done the simulation, and the facial mask has extremely important role. But when we operate SEIR model, we apply only SE, not the I, because we don't regard this as infected. So we only regard this being as exposed. So SE, not all the way to infected. So we do have parameters, and we apply that, try to understand, even though they were in contact, but are they really infected? So that's why we have done the Monte Carlo's parameter simulation. So we've done this, and then we calculate exposures. I have shown you the animation, and some of them turn into red color, and then they turn into confirmed cases, especially in a crowded area. So we do all kinds of simulation. Anyway, we input all kinds of data and we fuse them. It's not 100%. We don't need 100% data, but smart card data are extremely important. So we do simulation. And actually, it took more than 10 years to realize this work.
감사합니다.
Thank you for the comment. As I lead the discussion, we have some questions from YouTube, so I would like to walk you through a few of them. There's a question regarding various public data of the Seoul metropolitan government, and our institute also share some public big data through MOU with the Seoul metropolitan government. So we have lots of these type of public big data, and after our 4 presentations, maybe we have a different types of big data we talked about, and maybe we can think of some public data of a Seoul metropolitan city after applying some of your research among your presenters. As far as I know, transportation data is one of a major example of Seoul metropolitan government, and Professor Lee Seung-jae has utilized a lot of these transportation data. So maybe I want to ask Professor Kim Tae-hyung, because I want to listen from various professors.
I published 3 single-authored papers in top quality journals this year, and I used the Seoul survey data set. The Seoul survey was initiated in 1993, and we collect data set from about 20,000 households. And considering their mean the household size, you can get data set from 40,000 individuals. And I believe the metropolitan government will include survey items on COVID-19 and its impact on their perceived risk and quality of life and their well-being and so on. So I look forward to it.
네, 감사합니다.
Thank you. How about Professor Benjamin Heidecker? I want to ask a question. So in Seoul, we have lots of public data. Through MOU, Seoul metropolitan government can provide and has been providing various public data to various R&D institutes. And how about in UK? Is it easy for researchers to get some public data in the UK?
Yes, thank you. We have data access and data protection laws in the UK that mean that any member of the public can inquire for access to data that affect them. And the response of government to that is, rather than push members of the public to make this access requirement, the government publishes lots of data. Of course, the data must be free from identification of living individuals, but generic traffic usage and even smart card data are now readily available on request from transport providers. This provides a huge database of individual travel behavior. So, for example, the underground system, where smart cards tap in and tap out, we can get a very rich data set of the transport system usage. And that can be negotiated quite readily with our colleagues in Transport for London. What it tells us is where the transport system is used. It doesn't tell us quite so much about the travel behavior of the individuals. We don't know where they start their journeys and where they end their journeys. But it provides the kind of information which, if we go back some decades, that information wasn't available at all. We couldn't see it. Over a long period of time, our government has published aggregate data at a national level. So we know vehicle kilometers of travel, perhaps by different road kinds. We know safety data. There are the usual high-tech providers, so Google and others will release anonymized data. In fact, that's readily available through travel apps, but we don't know how uniform that data is. It's only from certain members of the public. There is a risk involved in data of that kind of marginalizing those who don't already use. And we are sensitive to that in our use of the widely available big data sources when it comes to making policy decisions. We do not want to exclude the non-participants. So we have lots of sources of data, but we must use them intelligently ourselves.
오케이, 감사합니다. 사실은 우리
감사합니다.
그 아이랄 교수님은
Professor Ayral,
서울에서 코로나 이후에 어떻게 바뀌는지에 대해서
She talked about the urban space after COVID-19. And Professor Ayral, I believe you have used a lot of data from Seoul. What kind of data did you use? Were you able to easily get those data? Can you answer that?
Thank you for the question. I will answer in English. In my case, as I'm very new in this field, actually, as a very young researcher, also a very newbie in Korea also. I just came last year to Korea, so I'm not very much familiar with research database and so on. So our research lab members especially were really helpful in reaching this data. And what I found very difficult as a researcher is that I need to know really specific keywords, what to search in Korean, and I'm not sure if my Korean is enough to make this kind of detailed searches, so I had to ask for help, of course, always. We worked from Seoul Open Data Plaza. We tried to find information from there in our research lab, but maybe by the time now that we are utilizing this kind of data very often, I think it may become also more available to public. When we were talking about this, like reaching data issue, I was also thinking like it's not so easy yet for us. And I also thought about the case of Barcelona. Barcelona is also, as the city level, they are working very much about how to make public data for citizens. And they started to use this term, a keyword like digital democracy. So they are like trying to educate the citizens about how to reach this kind of urban data, how to benefit from this kind of data collected, how we can understand the dynamics of our own city as an inhabitant, which I found as a case study very useful. Unfortunately, in Turkey, we don't have a good case study, so I was like thinking about the case study of Barcelona. So as a foreigner, I would really wish to reach maybe a bit more easily or find maybe some specific database for reaching public space data, for example, especially. Because it looks like everything is a bit together without the categories, and it makes it hard, especially for a foreign researcher. But I'm sure with the technologies and the resources that we have and all these research projects that we are doing in the city of Seoul, I think it will encourage making the data even more public and more accessible in the near future.
네, 감사합니다.
Thank you very much.
또 편하게 이렇게 질문 있으시면 서로 주고 받으시면.
Any questions you have, please? What about you, Professor Park In-gyu? Do you have any questions?
제가 질문 드릴까요?
Okay, maybe it's my turn to ask a question. Maybe
저기 바뀌는 시간 타임에 차이는 있는 것 같아요. 저는
I guess it's my
하이데커
turn. I would like to ask a question to Professor Heidecker.
먼저 그 발표를 굉장히 재밌게 들었고요.
Very interesting
아까
presentation.
울레즈라 그러나요?
You mentioned about ultra low emission zone.
런던에 새로 이제 적용된
That area in London, specialized area in London, and with the powerful measures, you found the way to have the cleaner vehicles running in and out of London, and it was a great opportunity for me to get to know that there's such section in London. And as I'm a physicist, I had some question because I don't have a great background of this knowledge. And so when you created such a system, and some benefits you can expect include
나이트로젠 옥사이드,
nitrogen oxide reduction. Of course, it's obvious to expect, but is it because of the allocation of the section, or the actual COVID-19 fundamentally reduced the traffic? So I'm curious about it's somehow mixture of the effect of the ULED or the COVID-19. So I don't know whether you've researched on like how much percentage actually resulted from the COVID-19, or how much portion came from the actual allocation of the section.
Yes, crucial question, and thank you for that. So when we envisaged the study, we were going to use data for the implementation period all the way up to April 2020. And that would have included the COVID-affected period. And our possibilities were to include a special COVID intervention effect to isolate the consequences of COVID, and we would switch that in February, for February 2020. And that would then represent the additional effect of COVID over and above the ultra-low emission zone initiative. But in the end, we stopped the analysis at the end of January 2020. So before there'd been a marked effect in London of COVID, we excluded any COVID-affected data. Now, looking into the future, it would be very interesting to ask, after the ultra-low emission zone effect, what effect is there of the additional change in travel due to COVID? And then we could really see the relationship between traffic usage in London on the streets and air quality. There are, of course, other sources of oxides of nitrogen, and gas-powered central heating boilers, we now understand, are a major source. So transport is an important component of air pollution, but it's not the only one. And certainly we've seen big progress in the removal of added lead to petrol. It's historical now, that goes back to the 1980s, so 40 years ago. But we understand transport-focused interventions can make a big improvement in some cases in urban environment. But after we have addressed the transport issues, there will be other challenges facing us. So we have to work together with our colleagues, including in physics, in geography, in urban science, in planning. Transport has a role, and we're happy to collaborate. Thank you.
네, 감사합니다.
네, 감사합니다.
Thank you for your comment.
또 질문 있으시면은.
Any other questions?
저도 하이데커 교수님께 질문을 하나 드리고 싶은데요.
I also want to add a question to Professor Heidecker.
너무 흥미롭게 잘 들었고요.
Very interesting presentation, as mentioned a lot of times.
이슈를 다루고 있다는 게
It's quite interesting to listen to this big data related issues in the bigger context in collaboration with the field of environment, because
이 정책에 대한 평가
this special section, ULs, is also in a political, policy context. It was an interesting example, and I had some questions about that. First, if you have some regulations around the urban areas,
미해물질 배출이 줄어들 수가 있는데
of course you can forcefully reduce the hazardous and any harmful
오히려 확산을
measures, harmful factors.
관찰되었는지
And have you observed any impact of exiting vehicles from the center of London to the outside of London? And also, I believe this is the similar case between Korea and the UK, and there are more and more regulations on conventional combustion engine cars. And so in the longer term, with the introduction of eco-friendly cars, how much impact does the UK expect by introducing the eco-friendly cars?
Yes, thank you. Very, very interesting topic. And of course, regulating traffic in a small part of London, just 22 square kilometres, seems to have had an effect across the whole of London, over and above the trends that were already established. So our vehicle fleet, of course, is changing from the older, more polluting vehicles to Euro 6 standard internal combustion, and in due course we expect more electric vehicles. And one of the consequences of government policy is to help individuals make good decisions, incentivize individuals. So we're looking at the whole system effect associated with the timing of the ultra-low emission zone. There are many mechanisms, including incentivizing people to buy more up-to-date vehicles faster than they would have done before. So for a few people, it will tip the balance from an older vehicle, more polluting vehicle, to a newer one, so they can carry on driving into central London. And the effect of that will spread across London, because the journeys happen elsewhere as well as central London, for the most part. So we've taken a more polluting vehicle and substituted a less polluting vehicle traveling across the whole of London. That is one of the reasons for the spatial spread. But this takes us to the reason for introducing policy that affects everyone in the same way. And that is to help the individuals make choices that they know are good, but provide an extra reason to make those choices to the benefit of the community as a whole. And this I think is an important role for well-pitched governmental policy. So help us on our way. We expect this to happen with electric vehicles too. Electric vehicles have many advantages. We need help from the government in infrastructure, the charging infrastructure. That will be a major challenge. Laws that enable city dwellers to charge their vehicles at home. And in high density living, that is clearly going to be an issue. And many elements like that. We look forward to seeing how the government will tackle this. And the consequence is we look forward to cleaner, better cities. So all interesting points raised by your question, I think. Thank you.
네, 박인기 교수님, 네, 질문.
예,
Professor Park In-kyu, please go ahead.
이왕 질문한 김에 또 한 가지.
Okay, I would like to add more question. Now I would like to ask a question to Professor Lee Seung-jae.
약간의 그 수학적인 장난스러운 질문이 될 수도 있는데.
My question might be tilted to more mathematical questions or interestingly arithmetic questions. So let me understand this way. If people wear facial mask, the percentage of possibility of getting infected COVID-19 is reduced by 90%. And on top of wearing facial mask, but also if you comply with the social distancing, then the possibility of getting infected is reduced by 97%, which is almost not much differences. So social distancing is not that effective, but wearing facial mask is much more influential. And if I convert that number, if I wear mask, I don't need social distancing. Can I interpret that way? I mean, if I wear facial mask, I can just sit right next to another person and be with him, right? And I wouldn't still get infected, right? Well, it's a great question. We've done numerous experiments and tests of wearing facial mask. This is not unidirectional, but the test was more bidirectional. So we inhale and also we exhale the droplets and etc. And
거의 안 걸리더라고요, 실제.
well, wearing facial mask is a great protective methodology, and we realized that facial mask is extremely influential, and keeping social distance is like the narrowest distance was 50 centimeter, and 50 centimeter of keeping distance between me and the people right next to me, you will not get infected if you wear facial mask. However, in studying the epidemiology, we call about the COVID-19 is equal to the droplet, right? Which means that like your saliva is dropped, but if you wear a facial mask, there's no droplet at all. And I told you about the best case and worst case, and your saliva or droplet, if there's nothing like that because you wear a mask, then you will not get infected. But there's also infection by aerosol, means that it's 10 to 9 and nanoscale. We measure that, but actually aerosol can be spread to the nanoscale. But the people working at CDC, they've done the epidemiology study, and then they said that still there's a lot of possibilities, and they are worried about this aerosol infections because there are things that we cannot see but floating in the air, and we can get infected, but we don't know what's in the air. That is why we keep emphasizing the importance of the ventilation. If we ventilate frequently, then the fresh air comes in, then it's okay. However, sitting inside the metro could be dangerous, but if you keep opening the window and then ventilate, then all of these dangerous elements floating in the air can disappear, and wearing a mask can also protect yourself. So as long as you wear a facial mask, you will almost never get infected. And I also look at all kinds of literature inside the metro. Were there any cases that people were infected inside the metro? And there were none, not at all. Of course, if you study the pathway of the people, infected people, I don't know exactly, but most of the infection occur according to the CDC. When I look at because we get all kinds of data on a real-time basis, we get all those data, and they are in our DB, and not a single case actually happened or confirmed cases happen inside the mass transportation. And in Wuhan city of China, there's one case inside the bus. So there's only one case inside the bus happening in Wuhan city, but in Korea, not a single case, not at all. No one get infected inside the mass transportation, not at all. So COVID-19, the greatest impact was given to economy because no one moved around because of the lockdown, and more than 40% of the influence actually happened to the economic detrimental impact. Around 300 billion won subsidy is given to the mass transportation, including bus, but now it's about 700 700 billion, and also metro is 700 billion. So if we add both, it's 1.4 trillion subsidy was given to bus and metro. That is a huge burden on Seoul Metropolitan City government. And if we do more tests, or if it's proven that wearing mask is a perfect protection, I'm sure that we can recommend people to move around. And of course, there is a vaccine available now, finally, it was proven, but there's also issue of the cold chain storage, etc., and also distribution. So the vaccine will be available in Korea only in the later part of next year. That means additional burden will be given to the Korean economy, but until then we can wear facial mask, we can protect that. If that is true, then Professor, I have a question. Based on your experiment, can I say this? Can I come to a conclusion like this? Let me say that. First, you go to the restaurants, sometimes we take off the mask at the restaurants, but if you wear mask inside the mass transit, not a single case of the infection happened. So any kind of social activity is possible as long as we wear mask. Am I correct to say that? Am I correct to interpret that? Is it correct? Because people's movement is excessively controlled nowadays, and like if we are not allowed to even gather at a church for worship, right? Well, my personal view, that what I said to you is a personal view. So as long as there's a minimum risk, people try to avoid that. But it is purely my view that facial mask is the greatest advantage. The biggest issue is the going to the restaurant. If you take off your mask, and you shouldn't eat with the other people, taking off your facial mask. Also, social distancing is extremely important. The facial mask on top of because wearing a facial mask gives you the social distancing impact of like putting a 1,000 centimeter or almost 10 meter of the distance between you and the other people. And in a closed room, probably we could come up with a different result. And mass transit operator, they need to constantly ventilate. And the last slide that I have shown you was the case in Seongdong district. They tried to come up with a more smart operations with mass transit. The ventilation is done automatically, and then they keep getting rid of the waste in a very clean way. How should I say? They have special disposal systems, and this heat detect system is also operated automatically. It's a really high-tech. And if you install these high-tech facilities on the mass transit, and I think it would be quite okay. That's, of course, my personal view. So let me say that you need to do more research, right? Okay, yes.
네, 좋은 질문 대답 감사드립니다.
It was a wonderful question and the answer, and I also found a question from YouTube I would like to present to all. Of course, we are talking about in the big discourse called COVID-19, lifestyle, life, and changes in life. Synastic socio-economic status can vary, and what kind of implications do we have? And I think it's very difficult to elaborate this question. Anybody wants to? Okay, maybe Dr. Idol.
Understand the question correctly, I hope. We are talking about the inequality that we are facing in terms of dealing with COVID, I think, no? Like in terms of race, ethnicity, socioeconomic status, and how it's impacted by COVID-19. I imagine the question is about that. So it's also one of the subjects that I usually try to focus during my lectures a lot, because of course, more disadvantaged segments of society and also underdeveloped countries, to say in quotation marks, underdeveloped countries are facing with, of course, more severe impacts of COVID-19, which I always also try to underline in terms of also usage of public space was one of these, but even more than that, thinking of this situation, socioeconomic status, especially in underprivileged communities, we can see this huge difference with dealing COVID-19 because there are some parts of the world who are dealing with this pandemic as much as we do, but we are not in equal conditions because in some parts of the world, there are still people who cannot even reach to clean water. And we say like, wash your hands, wash your hands. But there are so many underprivileged communities in the world that they can't even find the clean water to wash their hands. And they are like lacking all these basic services in their communities. Which also shows us a lesson also taught by COVID-19, this inequality between communities in the world. And in terms of also having adequate housing, people with shelter, we have a place to go inside. We can practice social distancing because we have shelters. Or we have enough economic sources to just buy our own cars and stay away from crowds in some cases. But there are so many people who don't even have a home. They don't have the shelter. We are talking about homeless people, for example, and they are almost like maybe 100% more susceptible to the virus because they cannot benefit from all these basic shelters, infrastructure, and any kind of like basic services that we can benefit from in developed countries. So COVID-19, I think, showed us this inequality between communities very seriously, which tells us also the future planning or future source distribution equally between every community, helping the vulnerable communities, because we are all fighting against this as a whole, like global scene. We are not just fighting individually, but it's something that we should be taking action in the global scale. So we should be maybe thinking of helping the vulnerable communities, creating more sources for them, and helping underprivileged people, because like this is a basic human right actually that we should be focusing on all together. And this pandemic, I think, of course, it's such a big crisis for us, a very negative thing. It's impacting our daily lives. But while thinking of the people who are really struggling in much worse conditions, we are probably much luckier than what they are facing, I guess.
네, 그 유튜브 상에 올라온 이어지는 질문.
We have more questions posted on YouTube. I believe some are similar to what were already presented. So if you think of and consider the personal trait in order to proceed with some new policy, maybe person-specific, individual-specific information may be an issue to deal with as a data set, to use more micro data characteristics, demographic characteristics, and other factors are available, whether it's available or not for the public data. Maybe Professor Kim Tae-young and Professor Lee Jae-hyung have more experience about public data.
This aggregate data because of the privacy issues, and so I used only the macro scale aggregate data sets for my studies. And so, well, I'm not sure if I can be given the chance to use the micro scale data sets. So I understand the demographic characteristics on the macro scale doesn't necessarily represent the wealth, age, or income of the individuals living in the city or the district. So let's say, well, you live in the Gangnam area, which is considered the most affluent district in Seoul, and it doesn't mean you are rich or you are more. You have more availability in terms of the mobility and something else. So I think well maybe one of the discussants can provide insightful answers.
제가 좀 도충 설명할까요?
I would like to add on that.
뭐 요즘
For big data,
빅데이터라고 하지만
we are living in an era of big data.
다 구비하는 게 어렵거든요.
It's impossible to equip the big data in every single metropolitan city. Macro data and micro data are all mixed together.
개인에 대한 행태라든지
And in terms of personal traits and some details,
돈도 많이
probably these type of data cost more money. So maybe you can establish this as a panel data in more different units. But macro data, maybe it's related to more socio-economical factors managed by national organizations. But we need more micro data, I believe.
매크로 데이터
So between micro data and macro data, how we converge, it is the question. And
로 에미션
we just heard the London's cases of these ULEs, and imputation technique is applied, and it's important to do so. It's a one way of statistics, and well, we need micro data, so we apply such methodology. But population generation synthesized, so-called, we create a virtual population for the research in order to converge the macro and micro data. So it's and also simulated with technique.
난리냐 난컨벡스를 묻는
It asking about non-convex vectors, and then you can generate some data from that.
Maybe the Professor Benjamin Heidecker can comment how to impute the data for London cases, right?
Excuse me, Professor Lee, could you repeat that?
Can you comment how to impute data, missing data in London case, right? Yeah.
How did we do it? Yes, and this is a delicate, sensitive issue because we want to base our analysis on real data. For our methodology, we needed continuity of the time series. Otherwise, we couldn't apply time series analysis. That forced us to come up with some values to infill the incomplete time series. And we employed a model to do that. So there are several different choices. One very simple one is to substitute the mean value for every missing observation, mean of the time series, and that of course reduces the variability in the time series, so it changes the character. In the end, we adopted the mice method, which is the best we could find, but it still corresponds to using a model to infill the data. That means our results are based on a model of a model. And a sensitive issue, and it undermines the strength of the findings. The proportion of data for which we had to do this is small, so as a matter of faith, we have to suppose that the influence on the conclusions is limited. There's an interesting prospect for doing huge simulation studies to repeat the infill process many times with stochastic variation, and perhaps to simulate missing data in the time series, which we did do in another study. We take a complete time series, remove data, and then use the mice method to infill and see how much difference that makes. So we've done that for a time series without an intervention. We did not test the effect of doing that on our estimate of the effect of the intervention. That would be a very interesting study, but one that we have to leave for later. It's a very interesting methodological question. What do we do when the big data we have are incomplete? do we do the best we can with the data we have got, or do we try to supplement the data as we did in our study? So very, very interesting, and I think important to understand the effects of what we do on the conclusions we draw. Of course, we're going to be seeing more use of big data in the future, but I think we have to do this with a good level of awareness of the methodological implications. So, great question, Professor Lee. Thank you for that.
Great. Thank you very much for your great comment. Thank you.
자, 이제 조금 약간의 이제 거의 이제 마무리.
I think we are going towards the end.
가서
Let me slightly change the topic of the panel discussion. One of the interesting parts, another interesting part is big data. And in order to process and analyze big data, high performance computer technology, supercomputer and storage devices may be required according to your assumption. Maybe anybody wants to make some comments about that? Professor Park In-gyu?
전문이시죠? 네.
It's your area. Well, I don't really have great knowledge of high performance computer. Well, of course, in our University of Seoul, we do have a set of the high performance data, but I'm not sure this capability is big enough to deal with decent big data. Maybe somebody else can add better expertise.
저희 그러면은 하이테커 교수님께 물어볼.
Then let me go back to Professor Heidecker.
100만 시간이 넘는
So you mentioned the data over 1 million hours, and then you processed with the statistic methodology. And in order to efficiently process, did you use any particular hardware, like a supercomputer, or any programs that you used? I'm curious.
Yes, very good question. The top line is each of the model runs took about 1 week. Okay, so heavy computing demand. And the software we used is implemented in the R language, so the Mars package is within the R framework, and I understand that's quite efficiently implemented. So it wasn't that was the problem, but the hardware we used is the UCL high performance computing facility, and actually it is a rack of many ordinary Dell PCs, but they work in parallel. So it's massively parallel Dell PCs with the sort of amount of storage, RAM storage and disk that you can imagine. And we have access to that, but it was a matter of submitting jobs and waiting until the results came through. Some queuing, of course, but even if we had direct access to the computers, we could not expect real-time responses. Transport studies has a long history of absorbing all of the computing power that's available. We will find more interesting work to do, and indeed harnessing big data for our purposes is included in that. So more computing power, we'll be able to use it, yes please. On the matter of social inequalities in COVID, which did crop up earlier, in London, early on we discovered that 29 of our bus drivers had become COVID victims. They had died. and the fatality rate is about 1 per 1,000 employees within about a month of the start of the pandemic. And that represents a social inequality because that's the sort of death rate, fatality rate that is emerging now a year later. So we investigated that, and actually we used high power computing to do it, looking at airflow within the confines of a bus. Micro scale atmospheric modeling in an enclosed compartment. And that's the sort of thing using a combination of meteorological methodology and computational fluid dynamics with direct relevance to COVID and to transport and to social inequalities. So plenty of scope for computing, lots of things we want to do, and we hope to be able to do many of them in the very near future. Thank you.
Thank you. 이제 거의 시간이 지나서 저희
It's almost time to finish.
다시 말씀드리지만 저희
Once again,
세션의 주제가
the topic of our session was the urban life innovation and big data. By utilizing big data,
많은 생활에 도움을 줄
we touched upon various helpful suggestions to improve quality of life in the urban areas.
뭐 교통 분야
And we have two experts from transportation and one from urban planning and urban architecture. We have one professor. It was wonderful presentation. And we also have the two panel discussants. We appreciate it. And I especially appreciate Professor Heidecker attending and joining us in very early time in London. And
그 집중도가 좀 떨어질 수도 있는데
probably it's hard to focus virtually, and also some participants online we appreciate, and that wraps up our session. Thank you very much for your participation.
예, 안녕하세요. 전 서울기술연구원의
Good afternoon. My name is Kim Tae-yeon, head of the Smart City Department of Seoul Institute of Technology. Welcome to 2020 Seoul Big Data Forum under the topic of Power of Big Data in Times of Urban Crisis. We have been doing this event from yesterday till today. Today's session, this session will be the last session of the forum, and today we are going to talk about two different things. First, we would like to touch upon the Seoul Metropolitan Government's policy regarding big data, and then we are going to wrap up after that. And first of all, I would like to invite the team leader of the planning of big data, Kim Jae-bong, to have about 30-minute presentation. And after that, until 6 o'clock, we are going to have some discussion session. I would like to invite team leader Kim Jae-bong.
예, 안녕하십니까. 방금
Good afternoon. As introduced, my name is Kim Jae-bong, the team leader of the planning of Seoul Big Data. Today, I would like to talk about the policy direction of Seoul Metropolitan Government's Big Data. My contents is composed with the policy of Big Data of Seoul Metropolitan Government.
통합 저장소 사업을 소개해
And also, I would like to introduce the Big Data integrated storage. E-government of Seoul Metropolitan Government is outstanding around the globe, and based on this facility, we have various development of the systems in the past. In Seoul City, we want to disclose the public data, and we are highly interested in the ecosystem development in order to smoothly utilize the open source data.
서울시 빅데이터 정책은 크게
Our policy is composed with the three elements of the utilization of open and analysis, utilization, and the services. For the openness, we have the information and communication square and the Seoul Open Data Square.
빅데이터 활용 시스템,
We have a big data utilization system and Seoul Big Data Campus and the Digital Mayor's Office under the category of the service. Also, to utilize these analysis, we have various use cases in the transportation, welfare, and administration. In more details, first, we would like to mention about the internal data collection by researching the data, data processing and standardization, and the linkage and the utilization in order to provide the opportunity for the general public to utilize the public data. And we also provide the services for the general public, not only for general public, but also related organizations in order to establish the strong partnership with various stakeholders. Among various services, I would like to touch upon a few major services. First, Seoul Open Data Squares. Regarding open data, we have been highly interested and effectively responding to such data and such changes. And since May 2012, we opened the Seoul Open Data Square. So we selected some socially high value to improve the communication methods and the administration of data utilization. And we have about 6,692 types of data set provided in 12 areas. And in order to provide citizens' communities, we have a link, chart, and open API. We provided various data provided. In particular, in this square, data square, we have various apps by utilizing the data, including Seoul Metro Bus, and we have about 200 apps just like that. And then Seoul Bus, Yellow Dust, and Finding Restroom are the major examples of such apps. And if you think of the major data provided, there are areas of the administration, cultural and tourism, and also there are some areas related to environment. If you look at the usage status since 2012, with its opening, we have some bus data, metropolitan data, and we have more services available since 2016, and we have a significant increase of the number of the usage, and now we are more focusing on improving the quality of data provided. Next, our Big Data Campus of Seoul Metropolitan Government. Big Data Campus strives to expand the utilization of the data, and by analyzing what citizens want. And then we have about SPLEX Center in Sangham Center, and then we have about 32 seats of the analysis rooms, and we have about 33 seats for the seminar room. So anyone who is interested in utilizing public data, we provide such facilities and infrastructure. And to boost this usage of data, we have some branches by the Seoul Institute, Tips Town, and University of Seoul. Big Data Campus has a major data set in the area of the real estate, income, and credit card sales, and other migrant population. And these are about 4,500 pieces of data. And then for analyzing solution, we have provided 350 open source solutions, and we also try to provide decent services by applying virtual desktop interface. And so far, we have about accumulated visitors of 7,574 people while analyzing 1,238 tasks. And in the areas of 10 different areas, we are focusing on our
디지털
analysis.
시민시정실입니다.
Next, digital mayor's room.
290개 시스템,
We have 290 systems analyzing over 300 pieces of
콘텐츠 등을 기반으로
information and with the visualization pieces of information, and in terms of analyzing for public services like metro services,
디지털 구청장
and
확산도
we also support the spread of such digital mayor's office to different district offices.
교통 상황과
And with the interactive
수질 등을 한눈에
app, we are able to look at various urban issues like air quality and traffic issues, and we also can monitor our major project progress, and also we can have the real-time monitoring through CCTV in order to provide actions accordingly. Also, in real time, we are able to look into some administrative issues. There are some utilization cases of a big data. So far, we have completed about 52 tasks, and we first started with the nighttime bus route for the optimal route starting in 2013, and we have specialized the project since then.
From 2019 until recently, in all areas, we have identified areas where we can apply. So we have changed our tendency so that we can apply even to the private sector. Now, among the integrated and converged data, let me share with you the most significant one first. This is about developing and converging data in connection with representative company related to communication, finance, and distribution. So applications are urban planning, transportation, housing, education, tourism, economy. For example, application example could be like the regional bus routes or where it is operated and Seoul Getaway, city creations. In case of the finance area, we are gathering income expenditure data processed based on financial information of citizens. Application examples are policy making, supporting customized policy for each target, and also we are trying to provide more customized data. Let me share with you future direction of data policy. First of all, let's look at the big data trend. Major economic actors such as the central governments and cooperation focus on introducing big data policies, improving related systems, developing technologies, and securing capabilities, and they are competitively taking part in. So the major economic actors, they are focusing on introducing the policy, securing competency. So that is the trends that we are witnessing. Considering this trend, Seoul Metropolitan Government is focusing on enhancing the data management level so that we can substantiate the data usage and also maximize the efficiency of the administration work and also improve the data service. In the administration area, we can make a decision based on data and also come up with more systemized search engines and then connect that and with the data, converge that, and we can provide a converged or packaged service. In the smart area, focusing on the storage, we can simplify or we can integrate a way of providing the data service. As a way of doing that, we can create a value from data. We can also innovate our work based on data, and also we can upgrade the urban service based on data. Now, in the future, the data management of Seoul City will be, first of all, we'll build an integrated DB and provide a portal service so that value of the data can be shared. Based on that, the data will be generated, and then once again, it will be gathered back into a converged DB. That will be the system that we plan to build. Therefore, we can come up with a data management systematic systems and also administration data conversions, big data storage can be established, and also we can use this data with a platform. To realize that, we have a staged or level of the storage for big data. Starting from this year, we have launched the DB building system first. Data governance is the first stage, and we have the second year and third year will start with the central government and all the way. In case of the data convergence, transportation, facility, safety, environment, and smart city data will be gathered in the first year, and then economy, culture, tourism, urban planning, regenerations, communication, innovation will be addressed in the second year. In case of the hardware and software introductions, building an integrated storage will be mostly done in the first year, which is this year, 2020. In case of the utilization service, we will build it in the second and third year.
물리적인 구성 관점에서 1단계
From the physical stage, let me tell you the business scope. Safety zone, source data processing, service data set processing, hard platform constructions will be done during the first year stage. In case of the safe zone, it's for the operator in each department. They will gather the data, and then if there are any private information, we can screen them out and then exclude that. And also in case of the source data, from the primitive stage, if the private information is deleted, then we can reconfirm that, and then depending on the period, we can also accumulate that. Now, the service data set processing is using the source data. We can make a decision and then use that for our research. So exploring the data set and providing the service, the main area. Of course, depending on the needs, not only the data set, but also source data can also be provided as a service.
내외부 활용 서비스 제공이라든가
Now, internal service and also completing the service will be done in the later stage.
네, 이러한 통합자장서 사업을 통해
Through building integrated DB, we will secure environment to utilize the big data in a step-by-step basis. So in the future, collections and also storing the big data will be done at one place and will be connected so that the service can be circulated. The big data converged DB will be a part of the Seoul metropolitan government. So generation process, conversions and provisions will be done, and it will be connected with the other platform, and once again we will recollect those data. So this will be like a circulated service that we'll be doing. This is my last slide. The policy of Seoul metropolitan government's data is as follows. Our data policy is by 2015. It was like infant stage, but after that 16 to 20 is the expansion stage based on the achievements that we have made. For the next 5 years, from 21 to 25, we'll make sure that data will be analyzed and used for decision making, and citizen-centric big data will be provided as a service, and data governance will be serviced. Thank you very much for your attention. That concludes my presentation. Thank you.
예, 발표를 해주신 김재봉 팀장님께
Thank you, team leader Kim Jae-bong, for the wonderful presentation once again.
데이터라는 얘기를 하면서
When it comes to big data, we always talk about the openness of the public data, and among various related issues, and Seoul metropolitan government is always number one in terms of opening public data and has a great enthusiasm of utilizing such big data. However, in terms of a general public's point of view, you're not sure where public data is used and how it is helpful. And data is always updated, and even if you started analysis, but then in the course of repeated updates, you feel the fatigue of renewing each and every piece of the big data, and it is pretty difficult without any strong commitment. In that sense, maybe we need to look into more cases of what Seoul has established, and policy direction will be very helpful to understand. So this is quite a large topic to cover, but it is rare to have such an opportunity with the various by listening various expertise, and then that's why his presentation was meaningful.
오늘 패널 분들은 저희가
We have
서울
some panels
포럼은 서울시의 그 산하 기관 중에서 빅데이터
as
전문
from various organizations related to the Seoul Metropolitan Government, such as University of Seoul, Seoul Institute, and Seoul Institute of Technology, and Seoul Digital Foundation, who are co-hosting this Seoul Big Data Forum since last year, while supporting the ecosystem of the big data to improve Seoul Metropolitan Government's
두 번째 국제 포럼을
administrations, and this is the second of the forum, and we have been leading each session by these 4 co-hosting organizations, and on top of that we have a special session led by Seoul Metropolitan Government, and we have been leading such wonderful sessions. I would like to invite panel discussants. We have one of each from each organizer. From University of Seoul, we have a Professor Lee Hee-jung.
아직도 길어가지고 잘 모르겠는데
I'm not sure about the official title. Maybe he can explain. The president of the university has a great interest, and then they established the Institute of Big Data, and then Seoul Metropolitan Government also has a great support for the University of Seoul. So if we continue this collaboration, probably in terms of urban issues and urban management, the University of Seoul will be the #1 institute of nurturing talents in the future. Second panel discussant is from Seoul Institute, the Department of Urban Data and Information. Thank you. Head Kim Sang-il
박사학위 논문을 쓸 때 그때의
had some acquaintance and with me because I learned some elements for my PhD paper, and he has been helping, and he's been a practitioner in this big data area and especially statistics, and then he's a guru that you want to see in terms of the big data because he's a practitioner but also a great scholar. And his department is called Urban Data and Information from Seoul Institute. They not only collect data that they used to do in the past, they have created some specialized team to pay attention more urban issues at their institute. And Seoul Digital Foundation has the founding ground to resolve the urban related issues, and we have someone with us from Seoul Digital Foundation. Director Kim Eun-young is with us. And last but not least, we have a research fellow, Dr. Choi Jun-young of Seoul Institute of Technology. In particular, as mentioned, each session has been led by these co-organizer and co-hosts. Last year, University of Seoul was a main host, but this year it was the Seoul Institute of the Technology's turn, and then Dr. Choi played a great role to successfully host this year's Big Data Forum. For your information, Seoul Institute of Technology, we've established the grounds to establish a urban research center as of January 1st next year. We want to pay attention not only on the practical issues but the policy issues.
플러스 산업화라고 하는
And we also want to focus on another pillar of industrialization of the big data. So along with the internal support, we want to gather more support from the industry so that we can create a strong public-private partnership in this area. And that is why we prepared for the legal ground of that center, and there Dr. Che has more important role to do. And that was my introduction of each panelist from each co-hosting organization. We are supposed to wrap up and end this session by 6 p.m. But first, I would like to thank team leader Kim Jae-bong to be on time to wrap up his presentation, so we have more time among the panel discussants. First of all, regarding the Seoul Metropolitan Government's policy directions, maybe I would like to hear from all the panelists, and in the course of that, maybe you can come up with some questions or suggestions to Seoul Metropolitan Government. That's how I think it would be ideal to lead this panel discussion. And maybe starting from Professor Lee Hee-jung. So even after Professor Lee Hee-jung is done, maybe we continue with Director Kim, and then Head Kim Sang-il, and end the discussion with Dr. Che.
네, 감사합니다.
Thank you.
저희 그 시립대
University of Seoul
AI 연구
AI and Big Data Lab is the official name.
처음에는 빅데이터 AI 연구소만으로 했다가
Big Data AI Research Lab was the official name, but in relations with the Big Data Forum, urban science is the new area of study came into being. And I believe that University of Seoul is one of the most leading city in the whole world, that our president is also working on that area as well. So together with the data science and urban engineering, urban planning engineering is currently being done so that we can provide a better service, create a greater value. That is the direction of the president of University of Seoul. And we are carrying out diverse areas of research. And we have received the budget and support from the Seoul Metropolitan Government to secure infrastructure to carry out research. So not only in Korea, but also in Asia, we have the supercomputer infrastructure and data processing operation competency. We have secured talented people, and also we have built the collaborative systems together with the Research Institute in Korea. And there are numerous institutes operated under Seoul Metropolitan Government, and Seoul University of Seoul is one of that, and we are actively collaborating with other agencies. Now, in relations with the presentations that we heard, we were able to hear the directions of the Seoul Metropolitan Government. Of course, the future direction is not expanded to AI, but I believe we need to build a good infrastructure and in a very aggressive manner. Compared to any other cities in the whole world, Seoul is doing a great job in building the future directions. So I believe people working in this urban design or urban planning area, I believe that they heard the presentation in a very useful way. I'd like to make a few comments and also pose a question. Realistically speaking, we do have a lot of different kinds of the master plans, and I have worked in various fields, including Seoul Institute and Seoul Metropolitan Government. I've done a lot of research together, and only when we are fully prepared and have a structure to have enough depth of the discussion, that we can come up with a policy. But you know that that Koreans are notorious of having a culture of doing everything quickly. So whenever we prepare something in a hasty manner, when things happen, then later on we try to make up that. So big data storage, DB, or area of utilizations of the big data, I believe the corporate structure is not actively built or actively done, especially among the public agencies or within the public domain like urban planning, design, sports, environment, etc. The data that can be gathered and the process between the public institutions, they don't open these data. And big data lab that we have under University of Seoul, we have signed the MOU today, but we hope to work further with the urban regeneration department or other department as well. I sincerely hope that University of Seoul can play a mediator role or a central role linking all of these public institutions, but not only sharing the information among the public institutions, but also with the private sector. We need to build a platform where the data can be shared openly. And what I feel is that Seoul Metropolitan Government is building a DB, but in a way, you build a DB first, and then later on, you plan to come up with a plan to cooperate with the people. So I guess you need to open the data first. If a certain data is difficult to open, then maybe among the 4 agencies under Seoul Metropolitan Government, we can open our own data. Of course, we'll comply with the privacy or any other issues, but we can do the monitoring in advance, and then while we can open our own data and share those data. That is my comment. So plan first, fully plan, and then build DB or something else. And during the keynote sessions, we heard numerous times that the credibility or reliability of the data is extremely important, and also utilizations of the data in certain areas is important. Of course, gathering the data, integrating, and then we cannot regard that kind of data as a valuable data. We need to think about the gathering, the processing, all of that. Of course, the Seoul Metropolitan Government needs to screen those data, and when you undergo all of these value chain, and then you can truly say that data has a value. So I believe that a critical role must be played by the Seoul Metropolitan Government. Do you have any specific idea how to do not only generating and gathering the data, but also processing it? What kind of value chain are you going to operate? That is my question and also my comment. If another opportunity is given to me, I will ask another question. Thank you.
네, 감사합니다.
Thank you. You can fully utilize your time to present your suggestions, feedback, or questions. I guess I can summarize your comment in 2 ways. We should not only collect information, but utilize this on such platform. And you were wondering about Seoul Metropolitan Government's plan accordingly. And I believe there are some public-private partnership planned ahead. I think you can answer in terms of that points. Okay, let me answer. We have the collaboration with the 4 major organizations, which today we just had the signing ceremony of the MOU, and this big data governance MOU will accelerate our effort to develop big data tasks and establish further cooperation among these 4 major partners. And first task will be the sharing the big data set and the capability of utilizing such data. So not only using our storage, these partners probably should be able to fully utilize the data provided, but the way the data is shared may be tricky because we have lots of limitations and restrictions of privacy, and to be honest, I have some considerations regarding the privacy and the sensitive data. So maybe we should classify this data into different grade, so we can decide what to disclose and what to be used among Seoul Institute of Technology, Seoul Digital Foundation, University of Seoul, and the Seoul Institute in order to develop further use cases. And that is why we have the MOU signing ceremony today. So it shouldn't finish just mere event, but it should be continued as a further cooperation. And the second part, if I may answer, talking about data availability and data validity, well, we have lots of systems that we can apply. Maybe the first subject of item of survey was 500, and then some information system was about 230 that might be useful and meaningful for these partners. And some data are managed by individual departments, and others are managed by the central storage of the data of the Seoul Metropolitan Government, which results in difficulties of managing different scope and level of data. So I think the quality assurance is also another task that we should deal with. So in terms of standardization and the management method, we are concerning. And if you think of the value chain creation, and if you think of a Seoul Metropolitan Government playing a role, yes, we can do that in the course of the cooperation, and that is our interest to have a further and stronger and firmer partnership. And I just explained some examples which we are creating in cooperation with the private sectors. And once we gathered private-public partners who are interested and are capable to create a good model, and that's another consideration we have at Seoul Metropolitan Government. Okay, now Head Kim Sang-il.
As I briefly mentioned before, Seoul Institute is doing a lot of work in data analytic area, and Head Kim Sang-il, Department of Urban Data Information. Can you explain what you are doing? Well, Seoul Institute
부서의 명이 좀 개편이 됐고요.
changed the name of the Department of Urban Data Information. And under this department, we have a big data team for the first time this year. We've tried different things this year.
원래 이제 도시 정부
Originally,
그 원내
Urban Information Team, we mostly provide research support, so our work was quite limited, but we live in a different era, and the era requires data-driven research or data-based research. So the necessity and the usage have increased. So currently, within our research lab in relations with the research, the policy making, there are two major things that we do. First, most of the researchers, they have some difficulties in gathering the data. So through the preliminary research or gathering the data, they carry out the research. And in the case of our lab or our research team, we provide support so they can carry out the research in a more easier manner, or especially the information that there was no accessibility before, or the methodology that have never been tried before, but we try to link them. Of course, there are some risks, but still analytics and as well as the processing, even though there are some risks, we try to integrate them and then provide it. And secondly, in the era of big data, the citizens' request or citizens' aspirations or citizens' needs to be identified, and my team actually identified verify. And also, starting from next year, we will carry out a survey or research to understand the aspiration and wishes of the citizen. Next one, it could be quite regional things, but Seoul City set up its basic plan, and we do have a performance index, and Seoul Metropolitan Government wants Seoul Institute to monitor the performance of their policies. So Seoul Metropolitan Government has asked Seoul Institute to carry out the monitoring. So we've been doing it for several years, and we will continuously do so, and we will also try to explore what we need to do and come up with the documents, or for example, it could be Seoul citizens' welfare or the use of the Seoul. We can create a panel, we can understand the demands or try to understand the features of the Seoul city. All those items that Seoul Metropolitan Government would like to know, while the citizens would like to have, we can sort of do the research in both of the areas. I hope that all the related and relevant agencies can gather together to gather the data and carry out collaboration among the agencies. That is our plan. I guess that's sufficient, and I believe it is sufficient to introduce the department's work. Now, my question goes to the presenter, especially the presenter talked about the future work. And following up the Professor Lee Hee-jung's comment, let me add, I'd like to first of all point out the essence of the Seoul Metropolitan Government's future direction. Within the ID Center, they already have tremendous amount of the data, and I don't think that Seoul Metropolitan Government is planning to build an integrated storage DB just physically, but rather I believe what the government is aiming at is to simplify or streamline the process and storing and provision of the data, not only for the purpose of the provisions, but I believe as a way to carry out work based on data. You are trying to build a DB, right? In the sense, we need to break down the silos, and all the departments need to work together so that we can upgrade the data, and the data can be up to date, and then also archive all the data, and then open that data to the citizen. This will be a grandiose systems. Well, upon listening to the presenter's presentation, I imagined that kind of system. But here we need a standard and also connections or linkage. Of course, reliability was already mentioned by Professor Lee Hee-jung, so I am not going to talk about, but connecting the work and also standardizing the work and responsibility are critical. Of course, Seoul Metropolitan Government work until now is really applaudable, but you need to accelerate what you have been doing, and now's the time to do that. I will give an example. When Seoul Institute carry out research, sometimes there are questions that we need to understand about the usage of the Seoul land. And the best way to gather that information is also what's the tax imposed on the property. And that is why the Metropolitan Government tried to update this data, and the property tax data must be accurate. If not, then Seoul citizens might raise complaint. And the Seoul Metropolitan Government has this property tax information, and also the housing department has a different information, for example, about the construction related information. So there's no match between the building information. And I believe that So government does not have a rule to set out the physical status of the building management. And you need to connect the purpose of the building and also the existing building mapping. You need to do that and then connect that with like property tax information so that all the information can be connected. Here I'd like to emphasize the point of connecting all the data. So just building an integrated DB is not enough. Of course, integrating DB is important, but I guess all of these data must be well connected so that it can be used as valuable information. And another proposal that I'd like to make to Seoul Metropolitan Government is in relation with the reliability of the data. Yes, data needs to be open, but before that, we need to understand the potential, the possibility, limitations, the issues of the data itself must be screened. And I don't think the Seoul Metropolitan Government can do it alone, but we need to build an integrated system where all four agencies like SIT, University of Seoul, Seoul Institute, Seoul Digital Foundation can work together. Seoul government has SDOT, and also Dr. who presented said that focusing in visible data, turning that into visible data was difficult, but also there are some statistic issues that the doctor has identified and the causes and reasons why such inaccuracy happens. But I guess that can be regarded as a know-how, and if that kind of know-how from the academia can be delivered to the Seoul Metropolitan Government, then you can prevent making any kind of further mistakes, and then you can upgrade the quality of the data that you have and provide a high quality, accurate data to the citizens. So I believe this should be like pre-study, and considering the special features of all of these four public agencies, Seoul Metropolitan Government can give us work to pre-screen, pre-study this data, and then after completing the pre-study, and then when Seoul Government review all the result of that, after that, you can open the data to the citizens. So I guess just before opening the data, you need to undergo this procedure. So this is my proposal. Sorry for talking so long. Thank you.
예, 길게 하시지도 않았고.
You can take as much time as you want, and don't be sorry. And it was a very interesting insight and suggestions and opinions. Seoul Digital Foundation also has been very active by working with various entities and the general public throughout various projects. Maybe we can hear some of the examples from Director Kim. My name is Kim Eun-young from Seoul Digital Foundation. Through this year's Big Data Forum 2020, we have prominent speakers and panel discussants, and I've been spending great time learning a lot of things. As my organization's name suggests, we are acting as the think tank for Seoul Metropolitan Government in terms of big data, and one of the most important elements is the data in order to pursue the innovation in the time of urban crisis. Entering 2020, we have a data innovation team in our foundation in order to aggressively conduct some research projects. I would like to introduce a few of them first. Data utilization consulting project is ongoing. At the end of the Seoul Metropolitan Government's presentation earlier, Smart City officer was mentioned with the 6 different platforms called 6S, and they've been doing related work, and one of them is called S-Data, and then I believe the team leader Kim Jae-bong introduced timely and in detail. The creation of a data collection and opening and utilization of the data is highly related to this existing policy, and it's important here to connect the dots. And when it comes to utilizing data, processing and analyzing the data and creating AI-based models, these are the things that Seoul Digital Foundation has been doing. And in 2020, various projects were conducted by different departments of Seoul Metropolitan Government in collaboration with our foundation. So one of them is to detect the water-related facility accident and defect, and we are also doing the flexible application of the parking fee in Seoul metropolitan area, also real-time detection of the firefighting related facilities, and we also do some project, as also mentioned in the Big Data Forum, and we talked about the CCTV location and the defect detection of the sewage pipe. And we briefly mentioned about various programs in collaboration with the general public, with the support of Seoul Metropolitan Government. Well, the government is collecting and analyzing data, but in order to fully utilize, there is a long way to go. So, civil data collector is a new concept that we created. By having these citizens to go around to find and develop some tasks. Not only in the context of the social work, but also Seoul Metropolitan Government can conduct more projects to enrich the existing data, and through the education of data utilization, the Seoul Metropolitan Government can also provide more opportunity of job creation. So I believe that's very meaningful. And in terms of data validity and availability, I would like to add in terms of the variety of data types. In the perspective of data provider, we always focused on how well we can utilize the data. However, the space called Seoul Metropolitan Government, by considering the location and the status, maybe it's important to think to enlarge our scope of the data, because limited data cannot solve any problem. So if you look into some private data, you can create more useful services for the general public. So by developing some private related projects, it's something that Seoul Metropolitan Government can pay more attention. So there are some dilemma between the data protection and data disclosure. Well, of course, we have developed the environment for data, but maybe we can collaborate with the privacy-related organization. And if Seoul Metropolitan Government can lead this movement as a leader, maybe they can provide a so-called My Data initiative for the sake of the general public. I think that's what Seoul Metropolitan Government can do. Thank you, Director Kim. So you talked about the Data Convergence Institute and organization. I would like to hear more from Dr. Choi Jun-young from Seoul Institute of Technology. Maybe you can add more onto that, and I would like to hear more from Dr. Choi Jun-young. Hi, my name is Choi Jun-young from Seoul Institute of Technology. Seoul Institute of Technology was established in 2018, so not many of you are familiar with our institute. I would like to briefly introduce. As a science and technology organization, we would like to solve some urban issues. That's why we were established. And then based on the science and technology, it will be a great direction and breakthrough to solve some urban issues. And then in terms of commercialization, probably we can play as an important bridge role. So maybe we can have the functions of traditional R&D institute with some entity to introduce a new and innovative technology. So that's how we're different from existing institutes in the same area.
이제 대부분 이제 도시의 이제 기술 문제라고 이제
When it comes to science and technology related to urban issues, there are lots of elements regarding that. We are trying to have the systematic and the scientific approach, and you can find what we do. Safety and disaster protection R&D center and Fine Dust Research Institute, and we have many other departments related to different types of the urban issues, and we have various functions along with this various departments. And among them, Smart City Research Lab is one department that we have. So if you think about data science, and that's the department that you want to look into in our institute. So this doesn't belong to only one department, but is shared by many departments, interdepartment issues. So maybe the Seoul metropolitan government can also restructure their department. And we actually have a plan to restructure of our department in order to fully utilize the big data regarding urban issues. For example, Infra Lab does the big data analysis, and then Safety Infrastructure Lab also develops some prediction model for urban issues. And we also have other labs related to earthquake and climate changes, and they are also conducting big data related research. And then what Seoul Institute of Technology has suggests you our direction. And if you think of how long it takes, maybe we can play a bridging role, not only to provide support, but provide appropriate algorithm and methodology in order to solve these urban issues. So in that context, the data science that we think is related to various domain and cooperation and collaboration, interdisciplinary manner. So maybe that can go to the same to the Seoul metropolitan government. What we want to focus is probably the unstructured analysis. Unstructured analysis can detect abnormal symptoms of urban issues, and by converging various images and videos, we can predict some issues before it happens. And this is not something that the traditional data analysis or analytics used to be able to do. With a more advanced algorithm and more advanced methodology, we have some capabilities to do so. And in one session of a Seoul Big Data Forum, I actually presented yesterday by utilizing big data to respond to COVID-19 pandemic.
전염병과 관련돼서
And regarding infections,
통신 모빌리티 데이터를 가지고선
communication mobility data was utilized according to my presentation, and that could be used also as a great tool of urban development and more efficient disinfection activities of a big city. So anyone who has a big set of data can join the collaboration,
순수하게 만들어진 데이터를 가지고
and instead of just simply analyzing the data, but more fundamentally at the raw data level, we can restructure our approach to ultimately to resolve the issue, and that's what I would like to mention. And then, according to Seoul Metropolitan Government's presentation just before,
논의된 그 대부분의 내용들이 이제
most cases were introduced that I would like to hear, but because 4 of the partners signed the MOU with the Seoul Metropolitan Government earlier today, this will greatly help Seoul Big Data governance, and I am not sure how the future direction will go, but at least we can create a cooperative way to have a better big data governance for Seoul Metropolitan Government. So at the stage of the data collection, there might be some rules and regulations that need to guide us to create a better environment. However, let's say if the Seoul Metropolitan Government look into further about their laws and regulations and ordinances, maybe as a government body, they can have more abundant supporting schemes and then the development of the big data in R&D. Thank you, Dr. Choi.
저도 평소에 좀 생각
I also had these concerns, and please allow me to express that, taking these opportunities. We use the terminology or expressions of data, but data for the purpose of administration, or the data that we manage for the purpose of carrying out the administrations of the city. Well, actually, the data is not built for that purpose. Actually, we just gather the data and then we are using for administration purpose. So, team leader Kim Jae-bong already talked about it, and there are 518 systems or 200 different systems, and you mentioned about this different system, but in order to make investment for the IT, there must be some legal justifications and background, which means that each laws and rules must have the background or the foundations why we are building it and how we are using that. However, when we carry out each administration, some of the items or the purpose of the work that we do, we are not crystal clearly stipulating the purpose. So somehow we ended up using that, and system-wise, that is how we calculate 500 something number of the data systems or 30 terabyte or etc. So these are actually electronic records, not the data that we have accumulated for the purpose of administrating the city. So there are some facts or data that the citizens don't want to disclose, which means that with a third party, the metropolitan government needs to sort of process the data or purify the data. What I mean by purifying the data, that means the title or the special official's responsibility must be managing this big data, or a certain department must be built to manage all of these. which means that even though department has the data, they need to exchange the data, but whenever they do that, they need to write down the official documents and they get approval. Only then they can exchange the data, which means that according to the laws and rules, we are allowed to share the data, but legally it's not fully supported. So if we go down to the working level people, we already talked about 3 laws, but there are some data that needs to be protected, but well, we must exclude the data. But who does this exclusion from the working level peoples? They have additional workload, but at the same time, they don't have any responsibility to exclude them. So that's what I understood. In light of that, just building a storage DB, it shouldn't mean only physically integrating all the data that are scattered around to integrate into one place, but rather you need to think about a window, and a window where every data can be gathered, purified, processed. But who does that? Who identify these data can be disclosed, or these data must be excluded, or this should be actually protected? Who does that? I think you need to hire someone who should be responsible for that, or you could hire a third party or outsider to do that, or but we cannot just hand over all of this data to the private level. So which means that semi-government agency like us, we can do that, because officials working at the semi-government agency, we can address this work. So I guess you need to get rid of red tape so that we can do the administration work. So my conclusion is that we've been talking a lot about the governance, but the fundamental thing is that data is equal to the oil or the natural resources in the 21st century. But we need to think about the purifications and also distributing the data and then making a valuable asset. In light of that, once again, the semi-government agencies, which has a bigger autonomy than the government agencies to address this data, together with that, we need to build a system so that everyone can join freely. So I'm repeating myself, but this is critical, so we should never neglect this important point. That was my point. Now, we have exchanged the questions to the speaker, to the Seoul Metropolitan Government. And now, for the remaining time, the 4 agencies, SIT, Seoul Digital Foundation, University of Seoul, Seoul Institute, have carried out different sessions. Maybe you can summarize your own session, and then you can also talk about how you are going to upgrade the forum next year. So I'll be giving only 5 minutes to each party. So we'll start with Professor Lee.
네, 감사합니다. 사실은 이제 제가
Thank you.
기조 sesion하고 또 이제
I was participating in the keynote session, and I also have to cover my session that I was playing as a moderator. So maybe I need more than 5 minutes. Okay, I'm given 10 minutes by now. The overall topic of the forum was that power of big data in times of urban crisis, and we had a wonderful keynote speech along with the topic, and through the discourse and conversation we had such meaningful messages that I found. And in summary,
데이터 사이언스 또 도시 사이언스,
data science,
그리고 이제
urban science,
인포메틱스라고 하는 새로운 영역,
and a new form and era called informatics have been newly defined and established as a concept.
기반으로 하는
And fact-based urban policies and monitoring and management have been established in cities. And for the development of the economy and the nations, it has been positively working.
말씀드리셨고
And that was what I was told during the keynote session. And regarding COVID-19,
유사의 이래로 경험한
we are experiencing unprecedented changes that was also
체크하고
commonly shared in the keynote session. And to more rapidly tackle such changes and problems, technology and data-based policy development will result in the future and actually the survival of the big cities and their residents. And because that shows the risk responsibility. And the keynote speakers also suggested that pandemic like COVID-19 shows the different patterns of different countries, and depending on the economic and social status,
세계적인 어떻게 보면은 표준이라든지 대응의
maybe the international standards and the manual doesn't exist in order to tackle the common crisis, and that's how we are witnessing differentiation of the responding to COVID-19 depending on the countries. Therefore, data science and urban science and informatics can be utilized for the monitoring as an index and or as a standard. And the keynote speakers emphasized that it's important to share the trend of changes or even
그 데이터 자체의 공개 자체도 국가들마다
the openness of the data or data opening can be an issue.
오픈하지 않은 거에
China didn't open the public data
국가들과 세계적인
around the neighboring countries, and the neighboring countries started to learn that policy, and not only protecting
글로벌 시대에서
your country's own data, but also
협업 체계
it requires some sort of a collaboration, and that was also withdrawn from the keynote session. We have a new era emerged just now in the field of big data and AI, and it has a great potentials and have a long way and to go and have more room to improve. So these four partners of the Seoul Metropolitan Government can discuss various roles, investment,
투자 대비 효용을 높일 수
and we ultimately want to improve the ROI.
또 국가들 간에 있어서
Between countries and between cities, it's important to establish such cooperation. And today I was told by the presentation of the collaboration between Seoul and New York and Kyoto and New York, and we have various collaboration cases. And we didn't have a lot of people from Europe due to the time difference for this virtual forum. And then maybe next time we can invite some Chinese participants in order to enlarge the scope of the discussion, and
서로 공유할 수 있는 기준같이
we can create some index and criteria that we can share among these various stakeholders so that we can create some synergy effect. And then that's what I've been told during this whole forum. Today there was a session led by the University of Seoul. There have been a lot of activities introduced in the various contexts, in terms of the response to COVID-19. And when you use the public transportation, there might be some risks. However, if you keep your mask on, it's actually much less dangerous, and it's well controlled according to the speaker's analysis. And at the national level, regional level, and global level, COVID-19 response capability have been varied depending on the space and time, and it was a great opportunity to see all these presentation. And at the end of the day, we're curious about how our life will be changed, and maybe the new concept of a community space will be redefined. Maybe within 10 minutes you can get access to such wonderful areas. And there were also some discussions of why we need such areas. So various cases by utilizing big data about the past, present, and the future was discussed in terms of the quality of life of citizens, and it should be the ultimate goal for the development of big data utilization. And big data technology and smart technology will be a great tool to maintain the sustainability and have our life changed in the future. And we had a lot of questions and some comments through online as well, and it was excellent opportunity. Thank you.
김상일 박사님, 바로
Next, Dr. Kim Sang-il, I will give you 5 minutes.
저희 세션은
Well, Seoul Institute session, we discussed about urban sensor. That was the key theme, and also producing the real practical result, and also finding the implication for the future. We discussed about that. Well, let me tell you why we have chosen the topic of urban sensor network. As you know, Seoul Institute, we don't limit our data to big data. We analyze all kinds of data, we make it visible, we turn that into model, we apply that to our research. And each researcher, sometimes we are faced with the data that is so huge that we cannot even address. That is why this year we have carried out a couple of research. We didn't present it during today, but also we did a research about how the general populations, how their movement have been shrunken because of the COVID-19. We have done the research, and also based on the credit card usage data, region by region, what was the changes of the sales depending on the different regions. We also identified that, for example, like land or property transactions. Those are astronomical amount of data that cannot be analyzed or turned into a visible data by one or two researchers. So using the SDOT data, we have done the environment, identify the temperature patterns. And let me just publicize what we have done. Under the name of the Insight report, you can get access to the research result at the homepage of the Seoul Institute. Anyway, anything related with the urban sensor network, we have utilized SDOT big data, and the first research presentation was done under the topic of the identifications of the temperature pattern using SDOT big data in Seoul. And also we try to analyze these data together with Red English has made a presentation based on the making sense of the sensor data, how local environmental conditions add value to the social science research, and to what extent the sensor unit can turn into significant data. And that was presentation given by Environmental Neighborhood of Cities and Their Spatial Extent, titled presentation given by my Dr. Munyacha. Last but not least, Dr. Anda has given a presentation under the title of Understanding the Impact of COVID-19 in Singapore and Australia using Urban Sensor Network, because people carry mobile phones, and mobile phone can be regarded as a sensor. This is so-called in Korea as the population, and calculating this living population, we have also done, Dr. Anda has done a research on the living patterns of the living population during the COVID-19. So let me summarize. In relation with the urban sensor network, is the one that we actually install that can be regarded as a sensor, or second category is the mobile phone, which we can regard it as a sensor. The previous case, the sensor that we actually install, to what extent can we actually measure? And there could be some differences because the density of the sensor, the locations of the sensor, or the accuracy of the sensor, we need to overcome the hiccups or some errors or some difficulties. And all the researchers have pointed out that these installed sensor must be accurate enough to be able to use as a data source. And as you can see from Dr. English's presentation, the special value that we get if we connect that to the social science, we just launched the study on how we can add value to the social science research by using or making the sense of the sensor data. And Seoul Metropolitan Government plans to provide S-dot sensor data all the way installed in 2,000. Currently, there are more than 1,000, but plan to increase up to 2,000. Of course, the government will make a wise decision, but instead of increasing the number of the sensor in numbers, it would be more logical, more desirable to categorize into a very specific way what kind of items will be measured. For example, using the mobile data information, we can do the sensing, and definitely GPS or local informations, where, when, who was where. That kind of data is really valuable. And when we met with those data, what we found is that Seoul Metropolitan Government is gathering the data through KT or SK, who are the telco operator, and they do have this special ways to gather this data and use that. And there are a lot of meaningful data located within the source data. And each data that exists within each network, we need to get access to that network so that we can enhance the quality of that data and the value of that data. And instead of getting access to 1,000 sensor data, if we can get access to the raw data and carry out analytic work, then we can definitely increase the usage of that valuable data. That was the lessons that we got from the session that we had. I cannot represent the session 4 that we have preceded, but these are the summarizations of what I felt. Thank you.
김현 실장님 부탁드리겠습니다.
Next, Dr. Kim In-young.
디지털 재단이 주관한 세션은
The session that my foundation led was about urban innovation.
인공지능과 데이터 기반
By utilizing AI, we've seen some cases of introducing big data for the public services, and then we discuss various topics and use cases. And I want to pinpoint the 3 elements from my session that I led. First, learning data establishment.
가장 중요한 것들
The most important part of AI could be some findings of optimization. However, the most important part is the securing of the data. And then that was also commonly agreed during my session earlier.
발전을 하거나
And whether you develop from some
그런 환경적
areas, and when you have some collaboration between countries, Korea is still in the infant stage. For example,
하수관로 결함 탐지
there was the case of the model development of the defect detection by Professor Moon Hyung-jun of Seoul Sejong University. For the sewage pipe, there have been active support from the Seoul metropolitan government. However, he mentioned that some learning data required for the plate numbers of the vehicles. However, after 6 months of the discussion, the private partner finally dropped because of the lack of the public partnership support, and then they also had to import some face imaging from China due to lack of the public support. So various projects regarding learning will require some more big data. So if you think about some room to improve, still we are worried about learning, the field of learning, which requires more attention. Next, as Professor Lee Hee-jung mentioned, the international cooperation was mentioned, and a lot of participants agreed upon. A lot of participants agreed that data utilization is furthermore important in the pandemic situation like COVID-19, because if we have some issues at the national level, we may not feel more urgency of the international cooperation. However, such problem like a pandemic requires the full scale of the international cooperations.
이런 문제들은
So such problems can be well resolved in cooperation between neighboring countries. The types of data and update intervals are probably different, and that may hinder tight and closer cooperation in shorter period of time. However, in the longer term, it's obviously necessary, and it is important to secure the platform for such international cooperation. Last, we were talking about some data we need to well utilize, or some data that needs to be carefully stored. Well, data policies are important to be established, but it's also important to create a culture of awareness regarding how important the data utilization is. And as a lot of schools shown, data coding has been a fashion in public schools, and in the course of that, maybe the pupils and the students can realize how important the protection of their own services, and in the natural course of learning, they can realize how important this course is. And in a shorter period of time, as mentioned, the utilization of my data can be also a suggestion for the future. So my data is usually highly related to privacy, and in the field of medicine, and some information can benefit citizen for the sake of the citizens. So once the citizens have a consensus of how important these privacy is, it could be beneficial for everyone. Thank you. We don't have a lot of time, so I would like to have 2 minutes before finish. So let's just continue. In my session, we were talking about the utilization of the urban data to respond COVID-19, and we were talking about the context of the contact tracing, and in what environment and in what space the infection was spread, and then the presentation explained how systematically the information was collected, and there were some areas in Korea that were missing some important and necessary data, and then such data utilization is useful to create COVID-19 responsive measures. And once you created a data set, maybe the R&D institutes can utilize full capability to create a better ecosystem of the data. And we were talking about availability on site while utilizing the data, and the democratic governance and guideline is required according to the conclusion of my session. And then the UN Habitat also mentioned about Seoul as a global champion. So maybe the Metro Hub Center can be established in Seoul, because Seoul has a full capability. And after the MOU of the big data governance, maybe what we think of, if we think of what we can do, these ideas are useful. So in terms of securing data and any founding resources, especially University of Seoul has a decent high-performance computer for data analysis, and hopefully these four partners of the MOU can co-utilize what they have in National University of Seoul. So the joint research can be also possible with the achievement of the joint R&D. Maybe we can share the results in the next Seoul Big Data Forum to see whether we can further discuss the further cooperation.
Well, surprisingly, you have given me 4 minutes. I was expecting only 2 minutes, but before I wrap up, if any one of you have things to say, a burning desire to say something, please, I can give you 2 minutes. Thank you. Well, thank you for panelists. Thank you for summarizing. I truly appreciate summarizing your own session. 2020 Seoul Big Data Forum was held yesterday and today for 2 days. And until now, all the participants have joined virtually, and I truly appreciate your participation. And also the panelists, especially team leader Dr. Kim, thank you very much for presenting at the last session. Next year, we are going to host the 3rd Seoul Big Data Forum hosted by Seoul Institute. The forum that we are having yesterday and today, well, I believe that it was very substantiate, and of course we had faced a lot of challenges, but we grappled with them really well, and I am confident that yesterday and today's forum was extremely full of contents, but only one regrettable thing is that usually the forum is held so that we can beef up our networking. Of course, delivering the information, exchanging ideas is critical, and also contactless way of having a meeting. It was great. I mean, we were able to hear the presentation from people in London, New York, in different places, and in a way, because of the COVID-19, we had this chance to invite people around the world and being able to be connected contactlessly. So we transcended the time and space. So this was actually very effective, efficient, and amazing. And because we are human beings, I had hoped that it would have been much better if we could sit face to face and also strengthen our networking. And because this is networking, this is online, there were things that we couldn't discuss, because not only what we discussed during the forum, during the official time is important, but after the meeting, unofficial way, exchanging the views, having this kind of exchanges is more important sometimes. But I sincerely hope that next year we can have that kind of meeting. Unfortunately, yesterday and today, there is a peak in the resurgence of the COVID-19. More than 600 people were confirmed today, but I hope that the third 2021 Seoul Big Data Forum can be held physically. Well, I hope the Seoul Institute can host a great meeting next year. That concludes the Seoul Big Data Forum 2020. Thank you.